And to moderate the panel, we have Michael with us. Michael, the floor is yours.
Thank you. For me, it's the beginning of early evening. I'm not sure where everybody else is, but thank you for joining me on whatever time zone you're coming from. My panel here is coming in from Washington, D.C., Singapore, and Seattle. So thank you guys. I appreciate y'all being here. Let's go ahead and kick this off. I want to make sure that people understand that this is a conversation about how blockchain is enabling new technologies for space. I think it's an underappreciated topic. It's one of those things that I think will have some pretty important impacts into the future. And so let's go ahead and take it away. Justin, let's have you come up.
All right. Yeah, so I'm just gonna go over the fundamentals and benefits and hazards also of blockchain. I've been mining Ethereum now for the last couple of years, and I invested in Bitcoin pretty early, and I'm also a blockchain developer. So I guess that's why I'm on the panel. Yeah, I want everybody to realize what the blockchain is. The blockchain is a distributed ledger where everyone kind of agrees on what transactions happened. And in order for people to actually want to partake in this sharing of public ledger information, they have a reward system built in where there is a raffle that goes off. The original Bitcoin protocol, it's supposed to go off every 10 minutes. And so that incentivizes the people who are keeping track of the ledger, we call them miners, to go ahead and do that almost as like a public service. And I do think that people should be keeping track of the blockchain. It's an important thing. It's a financial system, potential financial system of the future. And so, yeah, one of the great powers and benefits of the blockchain is that it's immutable, which means once a block is written, you cannot go back in history and change it. And at the same time, you can go back and read the history whenever you want. Every transaction that's ever taken place on the blockchain is there right now. You can go and look at the blockchain, and there's a lot of analytics companies built around that very service. Another benefit is that it's decentralized. You're not dependent upon a bank or a government. One of the points I was supposed to address is how this is applicable to space. We're talking about the financial system, so it's kind of like asking, how is the internet applicable to space? Like, it's just a really powerful technology that has been built upon a lot of other really important technologies that I'll go over, and not this slide, but the next slide. I want to talk a little bit about the transparency as well. Bitcoin, there's two sides to every Bitcoin as well. One of the great benefits I see is that all of the spending goes on in this public ledger, and so you can actually see where all of the funds are going. If everyone were to register and have a public wallet address, we would be able to see where everything's going, and at the same time, Ethereum has taken that a step further and created a tokenization system where you can actually build decentralized applications and do smart contracts. But at the same time, because anyone can create a wallet, you can also remain completely unanimous. And so people have used it for nefarious purposes in the past. There was a guy called the Dread Pirate Roberts, and they finally caught him, actually. There'll probably be a documentary on that guy, would be my guess. But he set up one of the early drug rings that used Bitcoin to operate. I'm not going to go in too much into the weeds. I do believe that blockchain is probably the most important technology we've created since public-private key encryption. Blockchain builds on a lot of lessons learned from spamming that took place in the 90s, a lot of cryptographic technologies that we've created over the years, and at the same time, it's limited. There's well, not all of the different cryptocurrencies are limited, but Bitcoin, for example, is limited in the way that it releases the rewards to the miners. We've had new technologies like ASICs, which are chips that are designed specifically to help with the mining process. It is a very computationally expensive process, at least the proof of work. There's more computation that's gone into keeping track of the Bitcoin blockchain than any other computation in the history of computing. It's just a graph of how the coins are released. One of the things that a lot of people talk to me about, and it is a very real issue, is the amount of electricity and energy that we're putting towards mining. In the beginning, people would ask me, why would you invest in Bitcoin? There is nothing behind it. But there is an incredible amount of computational power and energy that goes into keeping track of this distributed ledger. There's been other kind of hiccups and things along the way. A couple of years ago, there was a bunch of initial coin offerings and chain forking and things. That's where the mining communities can't agree on which token or cryptocurrency they want to support. There's a lot of volatility too. I mean, a lot of these things we're working out slowly. There's a few shortcomings in the way that you can overtake the blockchain too. If you're putting forward 51% of the entire computational power, then you can actually disrupt the blockchain. And then hacking's a thing too. Most of the time when you buy and sell cryptocurrency, it's on one of the exchanges, and there has been a troubled past. A lot of those are getting worked out now. There was just recently a big a public offering of Coinbase, which is one of the major US exchanges. It's venture backed, and they just had their public offering. And you can do it through other services now, PayPal and Robinhood, and all of these services are popping up and making it accessible to everyday people. It's really it's a culmination of technologies and devices, and it's a really exciting time. But I wanted to keep it to 7 minutes, so I will yield my time. And I hope you guys have more questions about the blockchain.
Thank you, Justin. Appreciate that. We're going to move over to Z.
Hi, I'm sharing my screen right now. So basically, like Justin mentioned, I would like to address a little bit more detail about how exactly blockchain space can really interact together. And we are Space Chain, so we have a couple of ongoing projects that we believe will combine blockchain space technology really well. And we're already have been fully commercialized all these projects. So I want to kind of quick share some of the project. So we started 4 years ago, and so far we have launched 5 blockchain-enabled payloads. So the first project we have been doing is that we have been also mostly well accepted by a lot of the blockchain companies are we call it multiple C services. So basically, it's instead of one private key controls one digital asset wallet, we are generating multiple keys to keep it secure. Like Justin mentioned, a lot of hacking has been happening, targeted digital banks, custodian services, crypto exchanges. So we are trying to make a solution for this kind of enterprise to utilize our service. And so what we do is that we generate multiple keys and place one or multiple of those keys inside our satellite payloads, so to generate direct link, so to prevent hacking. Because when we study about how blockchain companies are actually getting hacked, it's really a lot of social engineering, a lot of local server and Wi-Fi related hacking has been happening. So we want to use the alternative way of transmitting this kind of private data to help to them to prevent this kind of hacking. So we can basically say unless 3 out of 3, 2 out of 3, 5 out of 7 keys are approving this transaction, it won't be sent out. So yeah, so basically this project is also being funded by European Space Agency. I think it's the first blockchain related technology was funded by European Space Agency. So not only we have been doing Bitcoin, but also we have been doing Ethereum. So we have launched 2 blockchain payloads to the ISS. So we have so basically we finished the installation and we have been serving commercial customers since end of 2019. So we have 2 active payloads right now and working on Bitcoin and Ethereum in the ISS. The second application, which is I think the most exciting one, and it's really upcoming, that we were establishing a global satellite-based crypto transaction device. So basically, we're working with a couple of existing constellation. So and we did something really interesting, I think, is that we are integrating a ledger, which is a Bitcoin Ethereum wallet, into a satellite phones. So with this kind of device, not only you can do standard satellite phone calls, text message, but also you can transact blockchain digital assets. So one of the things Jesse mentioned is, I think I saw on the slides, called stable coins. So there are many different kind of digital assets, which is a Bitcoin, Ethereum that's supported by computing power consensus. But also there are another category of digital assets called stable coins, which is basically one-to-one packed digital asset to fiat money, which is basically a digital version of US dollar, Singapore dollar, Chinese RMB. So what we can do with this device is that if you look at the map on the right side, so all the greenish blue area, as long as you're holding our device, you're able to transact Bitcoin, Ethereum, other digital assets, including the stable coins I was just talking about. So you will be able, even you are transacting 5 million, 10 million worth of dollars in many of rural areas that don't have ground infrastructure or financial infrastructure to support your daily transaction, you're able to do this kind of transaction with our device. And relatively the delay time is 5 to 15 minutes, depends on how jammed the Bitcoin or Ethereum network is, but we have been running a lot of tests at different locations now. I think it's a very important application because if you go to, for example, we're working with African clients, Southeast Asia clients that are relatively remote, and it's extremely expensive to build ground network and also financial infrastructure to support the farmers, the small business there. So we're working with a lot of big institutions to say let's not use a traditional way to banks unbanked, but we use more interesting new technology, empowered by space, satellite network as well. The third layer, the third project we're working is a more of a long-term project. So we see a lot of companies are trying to build their constellation. However, we think there are a lot of repetitiveness in between the constellations. So we're trying to establishing a blockchain protocol that can help company from different jurisdiction or from different countries that to connect their satellite together to potentially build a more decentralized satellite infrastructure. So it's the project is currently sponsored by Enterprise Singapore and the University UK. So we have been talking to many different kind of satellite startups to build this together because again, this is a relatively I think we're at a very early stage, but I think it's an interesting angle to look at it. Yeah, so like I mentioned, I think blockchain space the integration is really been coming up. We have launched 5 blockchain payloads, and I think many to come. So very exciting, I think integration potentially. And if you guys are interested, we can definitely talk more after session. Thank you.
Terrific, C. We're gonna come back, and Justin also. We're gonna come back to some of these topics in a little bit, so we've got some time. James, you're up next, please.
Yes, hello everyone. My name is James Burke, and I'm here to represent a project called MarsCoin. MarsCoin was founded in 2014, and it is essentially a fork of Bitcoin. It's designed to be the future financial system for Mars. Now, it's not exactly like Bitcoin, although it does share a lot of the same underlying concepts and technologies. But MarsCoin is designed to have faster transactions than Bitcoin. So it's optimized for quick and easy use, especially for transactions between individuals. And we also would like to add additional features to it that would allow other applications such as inventory and voting. I'll talk a little bit more about that. But the idea would be that we have MarsCoin up and running now. As I mentioned, it's been going since 2014. It's actively being traded on 2 cryptocurrency exchanges, xt.com and FinXbox, and it is easy to mine. I'm holding right now a USB key-sized Bitcoin miner, and it's one of the things Justin mentioned is an ASIC chip that you would use for mining. So this is a USB key that holds an ASIC chip, and you can use it to mine MarsCoin. You can also use it to mine some other cryptocurrencies as well. But we want for MarsCoin for it to be democratic, for anyone to be able to mine it. And so it's very easy to get a hold of one of these. This is called a FutureBit Apollo Moonlander 2 USB key. But there's a wide variety of ASIC hardware that's available. And we're even talking about making our algorithm even easier so you can mine it on a smartphone or a computer. Now, this is important because we want for it to be really easy to run a node on the MarsCoin network. We want to eventually have nodes across the solar system, and we have an idea to have nodes that are based in a solar orbit to facilitate blockchain sync between the Earth and Mars and other celestial bodies. MarsCoin has a very active community. We recently held our first virtual conference, the MarsCoin Expo, and it was all recorded, and you can find out more about the project and watch the videos on our site, marscoin.org. Now, I should mention, I'm also involved with a nonprofit called the Mars Society. And when MarsCoin was founded by Leonard Lopin, who's a German-born software engineer, lives in the US now, he was a Mars One candidate at the time in 2014. He was also a member of the Mars Society. And he decided that soon after the project was launched and the first Mars coins had been mined, he would donate a large sum of them to both the Mars One project and to the Mars Society. And now over the years, Mars One has turned out not to be a viable project. So I was able to work with Leonard, and the founder of Mars One reached out to him and asked him if we could transfer those over to the Mars Society. So now the Mars Society has a large amount of Mars coin, and as the value of Mars coin accrues, that's just going to help humans to Mars and advance some of the goals that a lot of us have in the space advocacy community to settle Mars. But it's not just an investment. As I mentioned, it is a blockchain. And so there's lots of features that you could enable on a blockchain. One of the ones I like to talk about is managing inventory and managing resources. So if you imagine going to the grocery store and picking up an apple, if you had the apple tied to the blockchain, you can scan a QR code on the apple and you'd be able to tell where that apple was grown and how it got to the grocery store, the exact route it took and how long it took to travel. You'd know the whole history of that apple instantly because it's all tied to the blockchain. We'd like to enable that type of information for the resources on Mars. And so one of the things we're working on now is an inventory system that we'll be using at the Mars Society's Mars Desert Research Station in Utah. That's a Mars analog facility that the Mars Society has been operating for about 20 years. And I'll be the commander of Crew 261 this December. And we'll be using MarsCoin to do our inventory. We're also going to be using it to do small polls amongst our crew if we needed to vote on an issue. We're actually going to have a way to use the blockchain to do that. And so this is just a couple ways to show the proof of concept of being able to use the blockchain for space-related applications. And so we're very excited about this, and I'm very excited to be helping out with the MarsCoin project.
Terrific. Thank you very much. We're gonna dive into that a little bit more here in a minute. I'm gonna take my 4 minutes of fame here. Justin and I are directors of the U.S. ISU Alumni Association. It was over the last couple of years, the ISU Alumni Association has managed a couple small projects. Nothing honestly too terribly exciting, but over the last maybe 6 months or so, 9 months or so, there's been a lot of reinvigorated activity with the U.S. Alumni Association. Angela will talk about that tomorrow or later this evening, depending on what time zone you're in. And one of the things that came up really early on was the desire to develop a scholarship program. So I'm here to announce and to thank James Burke at the MarsCoin group and Z Zhang from Space Chain. They have both committed, their communities and their teams have both committed $3,000 each, so $6,000 in scholarship funds to the ISU US alumni program. So we're super happy about that. Thank you very much, gentlemen. Really appreciate that. Yeah, absolutely. Everybody, they deserve some cheers here. So we're going to talk a little bit more about that. There's still some details to kind of sort out, but the general gist of it is that it's going to be 4 awards, 3 for SSPs of 1,000. What I got wrong? And 1 to the master's program out in Strasbourg. So that's how we're gonna kind of divide this. Maybe it's going to be 4 to the SSP, and we're still trying to work out exactly how that's going to work. But we're already working on those details. We've just formed a scholarship committee for the U.S. alumni program. So thank you, folks, gentlemen. Really appreciate your stepping up and committing to it. It was really interesting how it happened. The MarsCoin people hosted their expo, and one of the things that they talked about was how do we do things that get the idea of the MarsCoin out into the general public. And
into the space community as well, Michael.
Yeah, absolutely. Specifically into the space community. So with zero prompting from me, somebody in their community suggested that they host. Well, first, okay, somebody made a fun suggestion. There's a coin called Dogecoin that got a lot of popularity because they supported the a bobsled team, right?
The Jamaican bobsled team, among other projects. Yeah,
and so that attention. To get attention, right? And that was pretty quickly shot down. But then somebody recommended a really great idea, which was let's do a scholarship. Let's host a scholarship program. And seriously, out of 1,000 people in their chat room, in their Discord server, James is the literally only person who knew my association to ISU. So I sent him a private note, like I didn't want to make a jerk of myself. And I'm like, hey, by the way, here's my role, and he jumped straight on that. So really big shout out to James and their community at the Mars Coin group. James, I want to make sure you post links in the chat, please, for sure.
Absolutely, sure will.
And so, so what happened is we took this first $3,000 and I took it to the new chair, Angela. I said, "Hey, this just happened. What do you think about showcasing it at the alumni conference?" And that was pretty quickly, pretty enthusiastically approved. And then I brought it into Jordy, and he's like, "Yeah, okay, cool. It can't just be about Mars Coin. We got to kind of broaden that." So I'm like, "Well, I was one of the instructors for Z at the executive space course here in Seattle a while ago." And I knew what Z was doing with his space chain. So that became a super easy conversation to reach out to him. And literally in a matter of moments, they said, "Well, gosh, if Mars Coin is supporting this scholarship, we will absolutely back it." So, really, this was a team effort. Justin's been involved with blockchain tech for a long time, so just really want to say thanks, y'all. Appreciate that. And now let's dig in a little bit to these technologies a little bit more. Justin, I'm gonna ask you to. I know that James also has a horror story, but do you want to kind of dig into some of your horror story experiences with blockchain? Some of the hard lessons you've learned. I'm gonna share that I was an early adopter of Bitcoin, and I bought 9 coins over time, and was really, really happy when Bitcoin was at $900. And I'm thinking, there's absolutely no way that Bitcoin can go above $1,000. It's a nonsense tool. No one will ever pay more than $1,000 for this digital nonsense tool. So I cashed in all of my coins at just precisely when the market started popping, and I look at a current $35,000, $40,000 per coin price, and I think, wow, that would have paid off my mortgage.
41,577.
Right.
As of right now.
I think we all kind of have some stories, and this isn't all about blockchain. This isn't all about Bitcoin. There's thousands of coins out there. So does anybody want to kind of pop in and say, as a cautionary tale, any of their cautionary tales?
I don't know if it's like a horror story. I mean, a lot of the early crypto investors were invested in Mt. Gox. It was the largest exchange of its time, and the coins more or less disappeared. And they said to everybody, like, sorry, but they've been investigating that actually over the last couple of years. Because of the transparency in the blockchain, you can see where all of it went. And so there's a small chance that we might actually be able to recover some of the funds and redistribute it. I don't know how all that's going to work, but yeah, there's a paper trail. It's, that's why if you're doing illegal activities with real money, they say unmarked bills right in the description of the type of money they want, is because every Bitcoin is literally marked. There's no way of it, getting to a wallet unless you mined it, unless you were the lucky miner. But mining is another process. I talked about it pretty quick in my presentation. That presentation is supposed to be 30 minutes on its own, so I kind of glazed over how the whole mining process works in like 3 minutes. But yeah, that's about all the other horror stories. I spent a long time configuring my rig, more time than I thought it would take. and I have a master's degree in computer science. And so, yeah, the community is still figuring itself out too. That's kind of one of the exciting things, is you don't really know where it's gonna go. We've got shortcomings and things, and we're creating new solutions every day. There's all kinds of companies that are popping up, because one of the early things that I saw was that the original blockchain for Bitcoin only has 1 megabyte blocks, which you cannot fit a whole lot of information into. And so they've solved that problem. Ethereum and a lot of the newer non-legacy coins have new, better ways of handling that type of situation. But I think that the one that the community at some point is going to have to overcome is the energy consumption. I argued with a guy from the IMF about this last week. He was just very concerned about all the energy that the blockchain uses. It's not super efficient. We're going to have to find more efficient ways of doing things, or we just move all of the mining off into space, which I think is something that we should be doing anyhow. I think that's maybe like a long-term goal for the planet, is that maybe in 100 years, we won't have any mining on Earth. It's just not a good idea to rape the planet. It's, yeah. Anyhow, I'll get off my soapbox.
Soapbox is very appreciated. And when you, in this case, when you mean mining, you're not talking about moving dirt. You're talking about ones and zeros. And
crypto mining. Yeah.
Crypto mining. Yeah. Okay.
But at the same time, it's still not, it's creating a carbon footprint. And I think anything that creates a carbon footprint is not good.
Right. Absolutely. So Z, let's dive into, you have 5 assets in space already, right? So let's dig into what those things are, the process of creating that, a little bit about your financing, a little, and you know, I don't want to ignore Garzik. If you want to talk about, you know, the start of Bitcoining, let's talk about your business partner.
Awesome. Yeah, so I started the company with Jeff Garzik, who was a 3rd ever Bitcoin developer. So at the very beginning, Satoshi Nakamoto, the anonymous creator of Bitcoin, published this white paper on this, what was the nerdy form nerdy blogs. Only super ultra computer science geek will read about it. And then he sent it to a couple of, like a channel of early, we call the cyberpunk people. So basically, at the very beginning, Gavin Anderson, then also Jeff Garzik, which is my CTO now, picked up the white paper and then started contacting Satoshi Nakamoto, and they just basically say, oh, how exactly we're gonna transform this white paper to actually a project. So it was a GitHub project that nobody knows will go anywhere. So they are the early contributors. So another interesting fact is that at the very beginning, because the mining was very small, and with your home computer, you're able to mine hundreds of Bitcoin a day because it's just not competitive, and that's how the economics really goes. So at the very early days, because the early developer tried to promote the Bitcoin, and they say, if you come and to develop on the Bitcoin project, I will give you 100 Bitcoin. At the time, it's like $50 or like maybe $10 even. So Jeff publicly gave away more than, I think, maybe 20,000, over 20,000 Bitcoins. So now he thinks about it. I was like, what the heck? Did I teach myself? But again, like, it's very interesting because it's open source community. So without those efforts, it will never become big, and it will never have the sophistication, you know, on the community right now. But that's just an interesting thing to talk about. So in terms of
in case anybody's curious, that's $820 million in value. In case he ever wants to do the math. That's amazing. I've never heard that story about Jeff before. That's amazing.
Yeah, and another fun fact about it is that they had a huge, not huge, but like a big party when Bitcoin crossed $1, because they say we invented something that worth more than US dollar per unit. So they were so excited because they basically, yeah, they said, oh, it's a major milestone. But now you look back, yeah, it's just very interesting thing to think about. Yeah, so we started. So actually, the whole idea started about 2013. Jeff published his own little bit white paper, said having satellite network to support Bitcoin, because at that time the Bitcoin network was not mature enough, and his idea was, if you want to anyone have anywhere have direct access, it shouldn't really depend on the kind of local, how good the local infrastructure is. So because the different developer country already got that taken care of, and they probably are happy with whatever they're having, but a lot of less developed regions that don't have that good infrastructure can totally utilize this develop open source tool that can enable their financial freedom. So it's quite interesting. And but at the time wasn't right, and the money wasn't there, the technology wasn't there. So just fast forward to 2017, I came up with this idea by myself, and I talked to many investors, and so I got a first investment from Tim Draper, who has been my long-term mentor. And he said, yeah, and many other investors basically say, if you ever want to do this, you need to talk to this Garzek guy, and he is passionate about space and a blockchain combination as you. And so yeah, we met and we just decided to build this company together. So the 5 payloads, the first 2 payloads we are used some technology called a Qtin, which is a proof of stake algorithm, but it's kind of proof of stake version of Bitcoin. So at that time, we realized the proof of work algorithm is too energy consuming to be in space. We don't want to run full nodes, that gonna burn out all this, all the energy we have. So we test a lot of proof of stake related technology. However, after a couple of years, we still think we need to get in touch with the biggest community, most active community, in order to let all the people in the blockchain community know what space technology can really help with the general development. Also, as the space community, to know about how exactly blockchain can really implement in the space tech. So so we move on to Bitcoin, Ethereum, and suddenly we get a very good popularity among digital exchanges, because just like Justin said, for a lot of digital exchanges, when they are people are depositing their Bitcoin, other digital assets into their exchange, if they don't have the highest level of security, they're the honeypot of hackers, because they can literally transferring $100 million worth of digital assets, and with almost no way to to get it back. So our cybersecurity solution has we have integrated with 3 different kind of wallet and exchange company to basically utilizing something the hacker are not familiar with, and especially after we implement one with the multiple signature key wallet inside the ISS, but that gives a huge protection on the asset side, because in cybersecurity, especially blockchain cybersecurity, it's really about how much stake we're putting on the hacking. So I wouldn't say it's impossible to hack, but hacking has just takes so much effort, and it's so different from any other services that other companies are using, that figuring how exactly our encryption, how exactly our network works will take so much trouble for the hackers, that we basically a shield that bounce their attack, and they have the better time spending on hacking others. So yeah, that's exactly how the business works. And yeah, so far we have done out of 5 missions, so 3 of them are fully commercialized. 2 of them are a combination of government support, which ESA support, and then also some of the research funds that we have been getting.
You're on mute, Michael.
A year and a half into this, and I still can't figure out to turn the mute on and off. In the middle of that, Z, you said, when you were kind of showcasing the ability to use a satellite phone from anywhere to communicate, and the kind of non-localization requirement. I'm not going to talk to you. I want to actually switch that over to James, because James is about as non-local as you can get if he's able to, if his team is able to build a currency for another planet. So talk about why there's value in having a separate coin for a separate world. Like, what's the value of it? One of the pushbacks that somebody brought to me was, well, why have something other than Bitcoin?
Right. So Bitcoin by itself would be hard to use on Mars. You'd immediately fork the blockchain and you'd have an issue between
talk about what forking means.
Sure. So if you were going to send Bitcoin, a Bitcoin node to Mars, it couldn't communicate instantly with all the other nodes because there's a communication delay between Earth and Mars. 10 minutes up to 20 minutes, depending on the position of the two planets. And obviously, if the sun's in the middle, then you're not going to communicate at all. You need some type of node in solar orbit to do that. So Bitcoin by itself is not a multi-planetary currency. What we're trying to do with Mars Coin, to address your question, Michael, of why a geo-focused cryptocurrency, there's some inherent things we're trying to add that tailor the blockchain to Mars applications. So one of them is having a local blockchain on Mars amongst the settlements there that can transact with each other very quickly and aren't dependent on Earth. And so you're essentially have the Martian economy up and running when the first Mars Coin node enters the network. Also, as I mentioned, we're adding additional features to the coin to do other things than just be a currency. Because a lot of these blockchain projects, like Ethereum is a great example. Ethereum is not just a currency, it's a whole software development platform where you can create all kinds of different things on top of it. You could do something called a smart contract, which is a contract just like you'd have in business of, I'm going to hire you to do X, and once X is done, I'll pay you. You can actually put that into code so that when the tasks are done, the funds are automatically released by the blockchain. And so there's quite a few things you can do with a blockchain because it's software, aside from just transacting A to B currency for some other barter transaction. So that's one answer to that question is Mars Coin and projects like it that will come in the future are going to be specifically tailored to space applications and the unique environment and the unique challenges you have of trying to communicate across planets. And then, so the other thing we want to do with Mars Coin, as I mentioned, is we want to be the financial system of Mars. We're a decentralized project. Nobody sort of has the central bank of Mars Coin.
Right.
Everybody that starts up a node that runs the wallet on their computer or does mining, everyone is running a node and it's democratic. All the nodes are equal. They're all part of the network. And so the network, if it has more people using it, it's a stronger network. It's a more robust network. It's a quicker network because the transactions are being confirmed faster because there's so many people running nodes and mining to confirm the transactions. The more people there are, the faster and quicker those confirmations are going to come. So having that in place that we could use now on Earth today in preparation for humans to Mars, in preparation for Mars settlements, that's what we're trying to do. We're trying to take baby steps now towards building that future economy. And it's not just the future economy of Mars. I personally believe that the future economy of Earth will be blockchain based. And you already see, the Federal Reserve looking into the digital dollar. Some countries are accepting cryptocurrency as their main currency, starting to happen a little bit in Latin America. You have other applications too, like Honduras was using the blockchain for land claims and tracking title. And that's, the blockchain, it would be great for an application like that because it's immutable. You can't, once you put data on the blockchain, it cannot be changed. That's how digital currencies work. That's why you can't counterfeit them because the blockchain is a public ledger that's immutable. You can't change it. And so if you can put land claims on there and you can track how land is transacted between parties, or other things like stock. And that's why our inventory and voting also works the same way. It's on an immutable blockchain. There's no way to fake a vote. You can see exactly who voted and when they voted, and that can't be changed. That would solve a lot of election problems we're having in the US if they used blockchain for elections. So, there's a lot of work to be done. This is all very cutting edge stuff, but there's a lot of smart people doing the work right now. And so it's very exciting to see this stuff happening. And so anyway, that's what gets me up in the morning about it.
It is pretty amazing. I am not the same level of nerd as the three of y'all. I'm learning this stuff the hard way slowly, and I'm not particularly good at it. I'm gonna bring up a question from the Q&A, because I think it's a really useful question. What are your favorite books or other resources on Bitcoin and blockchain? I'd like to learn more about mining. So I want you to answer verbally, but I also want you to do a service to the community and write in the chat, like, if this book or that book, and links to things that are actually useful resources. Who wants to jump in first? Because I think all three of you have a master's in comp sci. I know.
Master in psychology.
Okay.
I've got a bachelor's in comp sci, but I have a whole ton of certifications from Microsoft and other places. So.
Yeah. I mean, all of you are pros in your field. I am not a pro in your field for sure. So answer the question: what kind of resources, Bitcoin, blockchain, and they'd like to know more about mining? Well, the first answer is join the Mars Coin team. And there's a whole thing, join the Discord server and there's a whole thing on mining Mars coin. So I'm just going to make that plug for you, but give some generic resources that people can use if they want to figure some of this stuff out.
I love podcasts. And so I'll listen to the Unchained podcast by journalist Laura Shin, who used to work at Forbes. She's very good, and she interviews a lot of the players in the cryptocurrency space. And has a news roundup. So I never missed that one. There's a lot of other great podcasts too. So I would, that's a great way to learn. I also, speaking of certifications, I recently got a blockchain certification from the Blockchain Council, and it wasn't that difficult. I mean, I spent a couple months studying for it, but it was doable. And I was starting, I'm relatively new to the space in the last few years. So, I definitely recommend folks check out the Blockchain Council.
Cool. Z, you also posted another podcast?
Yes, I listen to Palm podcast, which is a more on the, I think like that podcast is less technical, but it's more kind of commercial application side and investor side. And the books I would recommend is, I think the number one book in my mind is the Bitcoin Standard called. And so it's an excellent book if you're just want to learn about money or how money is created and why Bitcoin is important because of how money was created. So I think it's a very easy read as well. So it's nothing you you don't need any technical background to understand it, just to understand how from some barter to more like have some asset-backed medium exchange to gold standard and how it was abandoned and why Bitcoin makes sense. So yeah, it's really a history of money, but a very, very easy to understand. Also, I would recommend if you are interested not just on the Bitcoin, but on the how blockchain potentially can change how we the society work. I would recommend Don Tapscott. A lot of his books are quite good. It's a blockchain revolution. How exactly this technology going to impact us in next 5, 10, 20, 30 years.
Can you post the links to the Tapscott book and the Bitcoin Standard? I'm actually not familiar with the Bitcoin Standard one, so I'll look that one up. And then Justin, you posted a YouTube channel?
Yeah, that is Blockchain Bitcoin 101 Blackboard series. The guy who made those videos stopped posting videos like 5 years ago, but it's a really good resource. He's got a bunch of of videos. Some of them get technical. If you want to learn how to put your coins into cold storage, for example, you can learn it there. And there's all kinds of explanations that go in depth on how the mining process works. Yeah, some of the potential benefits, all of the underlying technologies. I really learned a lot of what I know about Bitcoin from those videos. There was a Netflix documentary on blockchain Bitcoin that I thought was pretty good. And then, yeah, if you want to be more privy to what's going on, there's different online communities. The Consensus group is the group that's developing the Ethereum network, whatever you want to call it. It's kind of it's a community. It's the fact that they call it Consensus, I think, is a very tongue-in-cheek, or I don't know. Yeah, it's a witty name of calling their community, and it's also the company. So
cool. I'm not sure. Is Consensus the group that bought the remains of Planetary Resources?
Yes.
It is. Yeah. Okay. All right. I didn't know that. I didn't actually put those two things together until you said that. Cool. Another question from the audience. Do you think quantum computers are going to destroy some of the cryptographic principles behind blockchain? Actually, I've wondered about that myself, so I'm pretty happy that somebody asked that question. Quantum, is it going to destroy blockchain? Because I think it might.
Yeah. So, okay. Basically, if quantum become very widely used, that all the existing, quantum gonna destroy banking. So that I can put it that way. So quantum gonna destroy all the encryption. So we already have. So it's not about if quantum will destroy blockchain or not. But I actually have something. I think blockchain can be better protected than any other centralized financial system or encryption system. Is that blockchain itself is open source. So the community will be able to react to new technology much faster than centralized technology. Because if you look at, all the banking system in the world right now being encrypted in many different methods, and there's this new technology and think of all the local, I would say, government or like a banking institution gonna make decision on if they want to update the encryption or not. That will take 5 years. Just the discussion and legal and when the implementation will be in 10 years maybe. But blockchain is because it's open source. Once the community recognizes the risk, they're able to update it a lot of these things. I'm not saying it's gonna have a fully protected, but it will be more updated than any other encryption there is. So another important fact to understand is that the blockchain 10 years ago from now is a completely different story, because it's really evolving concepts that it's not like a blockchain technology is this. It doesn't really work like that because of the open source nature of it. Then I think I would say it will keep absorbing what's the best available and having a slightly interesting democratic process in between. But again, to short answer is that I would say it will quantum computing will destroy all the encryption, but the blockchain actually has an advantage because it's open source.
I like that answer. The other two kind of nodding yes, that you agree. Candidly, that's a little reassuring because I've been a little skeptical of that myself. So I think that's an answer I'm going to dig into a little bit more. But I at least will consider that one because I was a little skeptical of that. So this tech is really truly 10 years old. Right. I don't know when the exact anniversary when Jeff was writing code, but it was about 10 years, right? Z?
Yeah.
Yeah. Okay. All right. So there's no way that the world in 1994 could have predicted what a graphical user interface was going to do to the World Wide Web. And there was no way to predict 10 years ago that blockchain and crypto were going to be dominant currencies in some circles. All right. So now we're all trying to do space stuff in one way or another. Pull out your crystal ball. You guys have a better crystal ball than pretty much most people in the space and crypto worlds. Tell me what 10 years from now looks like. Tell me what 15 years, 2035. What does that look like? We're going to go in order when we start. So Justin, we've got 6 minutes. Take 2 minutes. Paint a picture of what the future looks like from your perspective.
The Bitcoin price?
I don't know. I'm not saying Bitcoin price.
400,000
however you like.
Maybe probably 400,000 a coin. We'll see, give or take 100,000.
Answer it however you like. It's not just about price. It's about the technologies evolving to meet the world.
Yeah, I think we're going to have to find some improvement in efficiency to the way that it works. I think we might get to a point where everybody has a wallet, at least. That's kind of an important step.
Okay.
And on that note,
8 billion people have a wallet.
Yeah, everyone will be registered. We might have some kind of, I don't know, people love their privacy, but having a human registry is not necessarily a bad idea. And you'd be able to donate and give people money anywhere in the world, right? You've got a lot of good charities set up out there to try and go into Africa and help these people that don't have running water. But if you could just take those, your cryptocurrency and give it directly to them, you wouldn't have to go through all the other intermediaries. There'd be a system around that where you can keep track, and it, kind of lets you know you're a good person because you're helping people out. I think there's going to be a whole lot more services built around that, distributed services, decentralized services, things that a government can't shut down because it's on the blockchain.
Right.
You can't shut it down unless you take over to turn off the internet, which that's a whole different discussion.
Whole different problem. James, I'm going to come up to you last because there's another question. But Z, paint a picture of 10 years, 15 years out, 2035.
Okay. Yeah, just following what Justin was saying, that for example, China has famously banned Bitcoin 50 times, which is interesting because you couldn't really ban it, so that's why you need to ban 50 times. So that's kind of one of the interesting things to think about, because it's an unstoppable trend, I would say. I personally never met a person that
trend. That's pretty cool. I like that.
Yeah,
right.
That's because again, like I've personally never met a person that's fully informed about how Bitcoin and blockchain works, then say this is not a thing. It's not gonna happen. Like I never met a person that fully informed that and doesn't believe it. So, and also I never met a person that understand Bitcoin and believing it and using it, then suddenly say, I'm giving it up because it doesn't make sense. I never met a person like that. So if you know anyone, let me know. So, but so again, it's an instable, I would say thinking trend, also the technology wise, because if we talk about user journey, just like Justin said, we're working with African clients, Southeast Asia clients. A lot of local farmers, they need to travel 2 hours, 3 hours to the town that the nearest that have a proper bank, and when they want to do a transaction with, let's say Dubai, US, they go to the SWIFT system, and that's very expensive, and also it takes 7-14 days for the money to arrive, and they have, and also the existing establishment has no interest and have no incentive to build the whole financial system around it unless it's profitable. But for us, again, the open source nature, and also because empowered by the space technology, we do have a lot of access, globally. So basically, we're saying that it will bring a lot of the result of good works from all over the world to a lot of places that had previously been ignored. And I think that's just interesting to think about. So, think of in 5-10 years, it's I call it one of the Uber situation. So when Uber first started, everybody gonna protest, everybody gonna say no, 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 you know, and you know, I don't want to share my data. I want to, like, they're gonna come all those things. But when the technology is more convenient, it's better, and it's easier to use. And once you touch it, you cannot go back. Can you imagine we don't have a car, like, yeah, car calling app, like we just wait out and a wave. It's hard to think about, right? So I think it's a one of the Uber situation, because once you use it, you understand it, you couldn't go back. So go back to my initial statement. I never met a person that goes back. Yeah, it's an unstoppable trend, and so in 5-10 years, I think it's going to get bigger.
Cool. James, answer the same question 10 years out, 15 years out, but within the context of one of the questions that came through the audience, quote, I'm not going to Mars anytime soon, for example. Why should one choose Mars Coin over Doge? What are your 3 incentives for potential partners and clients?
Okay, so Dogecoin is very different than Mars Coin. It's inflationary, and there's going to be more Dogecoins created, whereas Mars Coin is scarce, just like Bitcoin is scarce. It's going to increase the value over time. What's going to happen, I think, in 2035 is you're going to have a cislunar economy. You're going to have people going between Earth and Mars, multiple settlements. And the blockchain is a foundational technology that's going to enable a lot of different things. It's like asking someone today that's just a regular person, how does the internet work? Do you know anything about IP, the IP protocol? They don't, right? It's going to be kind of like that. Blockchain will be used for a variety of different things. Cool.
All right. Thanks very much, y'all. We're going to sign off with everybody. Really appreciate all of your time. Z, it's just dawn for you now, right?
Oh, it's actually 8 a.m. in the morning.
8 a.m. Yeah. I kind of watched the sunrise in the background. All right, y'all. Thanks a lot. I appreciate it. We're going to move on to the next topic. Thanks for being here. And once again, to Mars Coin community and to the Space Chain people, the ISU alum from the United States, really appreciate your scholarships. Thanks a lot, y'all. Appreciate it.
Thank you.
Bye-bye.
Bye-bye.
All right. We are moving on, and I am the next speaker. So give me 10 seconds to kind of shift gears. Let me pull up my slides. Give me a second. Okay. All right. Okay, can somebody give me a sound check that you can see the main slide? Okay, good. Thank you. All right. Hi. I've really enjoyed this conference. 48 hours of continuous programming. Before I start, I just want to say shout out to Jordy and a huge team of volunteers, moderators, speakers, technical IT hosts. A 48-hour continuous event is really hard to do. So shout out to the folks that made this thing possible, because it's pretty darned impressive. All right, I'm gonna jump in and start. I do want to point out that the event was very graciously sponsored by the Aerospace Corporation. They've been supporting International Space University in a variety of ways for decades, and this conference is just one more example of that organization. And again, I'm going to shout out to the Mars Coin folks and the Space Chain people for sponsoring a $6,000 set of scholarships to ISU. All right, moving on. This is who I am, and I have a pretty interesting background. I'm not going to go into a lot of detail here, but it is relevant if you're talking about building space elevators. So, straight out of high school, I went into the Marine Corps. I had an amazing captain who taught me investment management while I was in the Marine Corps. So, my first job out was focused on investment management. Uh, Much to my great surprise, I was in one of the first wave companies of the internet back in 1995. So I've earned this gray hair the hard way. That taught me a lot. It taught me a lot about advanced technology. And I realized then that this was something I really cared about. I was very fortunate. I was able to do some real estate development, and that put me in an interesting position in my early 30s financially. And I was in this spot in my early 30s where I had choices people typically don't have in their early 30s. So that's how I got into space. I didn't even start until I think I was 31 years old. And we'll come to that in a moment, but that's when my career in space really kind of took off. So I'm the president of Liftport Group. We're going to talk about that a lot. I'm also a director at the Center for Space Commerce and Finance. And I think this event is my last official position as the president of the U.S. Alumni Association for ISU. I've been the president for about 2 years now, a little over 2 years. I am still a director at the ISU U.S. Alumni Association. And I'm really glad to, the organization is in good shape, and I'm passing the gavel to Angela Pura to take over as chairman. Okay, so I told one of the organizing committee earlier today, I was nervous about presenting my elevator stuff to the ISU community because I have a story to tell you. I had started working on the elevator back in 2001, the end of 2001. But I didn't go to ISU until 2008, the summer of 2008, the SSP in Barcelona. Many of my classmates, but not all of my classmates, knew my background. I was a little bit internet famous at the time. Curiously, all of our work that's pretty amazing behind me actually never got publicized because there was no such thing as Instagram or Facebook or YouTube or any of that stuff. But my classmates mostly knew, many of my classmates knew what I had been doing for the last several years. So I'm in this great big lecture hall, and it's, I don't know, we're towards the end of the classroom sessions, and one of my friends was kind of being a smart ass, and they asked Professor Telyarenko about space elevators. Now, I unfortunately, Professor Telyarenko died a few years ago, so I'm not sure who on this call remember him and who don't, but he was a truly amazing professor. I only had a few classes with him, the way you kind of specialize in SSP, but by way of background and heritage, he was an old guard Soviet space researcher. I think I heard that he was one of the inventors of the Milnaya orbit, which I think is pretty astounding. So he was a hardcore space rocket scientist. And somebody in the class asked about space elevators. And I remember pretty vividly that my friend raised their hand, asked the question, and then looked at me and smirked. So I remember that pretty vividly. And so to give a lecture to ISU about my space elevator always kind of triggers back that memory. So Professor Talyarenko, he stands up there and he kind of scratches his chin for a second, and he kind of looks away for a second. He's got a really thick Russian accent. I cannot duplicate, but I'm going to try. He's like, yes. Let's see. Space elevators. It is very interesting. It's very interesting. It is like flying carpet. It is a good story. It is not real. And that is my first official relationship to ISU relating to my space elevator, is that a guy I really, really, really respected comes up and flat says, it's a story that isn't real. So I always get a little nervous giving presentations to ISU because I really remember Telyarenko pretty vividly there. Curiously, and actually I didn't learn this until far later, Professor Chris Welch is actually a really big fan of elevators, and that's a whole nother story, but that's not the one that sticks with me. It's as Professor Telyarenko saying it was a flying carpet. I've actually had a lot of great support from Professor Welch. So if this is what you think the space elevator is, you're not alone. This is the early ideas of a space elevator. So imagine a ball and a string, spinning it over your head, the string in the middle stays straight. Now expand that to an Earth-sized system. The Earth is rotating. You have tension and centrifugal acceleration pulls that string straight. If you have a long enough, strong enough string, you can climb back and forth on an elevator, on a robot, back and forth to space. So back in 2001, 2, and 3, I was a part of the original NASA Institute for Advanced Concepts research team. I'm listed as number 2 guy in the acknowledgments. And for 2001, 2, and 3, it was a pretty interesting set of days. When the NASA money ran out, I told you I was in a pretty good spot financially because of my real estate developments. And so I decided to create my own company after that. So 2001, 2, and 3 under NIAC, and 2003, 4, 5, 6, and 7 as the first version of Liftport. But a lot happened during those years. And I'm going to stop sharing my screen for a moment and just kind of like take a look at some of this stuff in the office, right? So we did carbon nanotube development. I know you can't see this, but this is nanotech. We were trying to make extraordinarily long, strong strings. So we made some of the earliest nanotube threads. This is very, very brittle. It will not, I could pull it apart with my fingertips, but that we were able to take nanoscopic particles and turn them into macroscopic materials, that's a pretty big deal. Along the way, we were able to make new alloys that are pretty interesting. We were trying to make something strong. That didn't work, but we were able to make something that was very electrically conductive, which is, I think, also interesting. We did a lot of nanotech work. We got really good at building specialty strings. We were not very good at the nanotech side of the equation, but we did become quite good at building robots. So over here, you've got early designs. And then this one here, we climbed a mile into the sky. So imagine having high altitude balloons tethered to the ground with robots climbing back and forth. So we were working, even though we weren't very good at the materials side of things, well, we were quite good, we just weren't successful. we didn't make a strong string, but we were very good at building the mechanical processes of climbing. And that seems pretty straightforward. I assure you it is not straightforward. So that's kind of where we were 2003, 4, 5, 6, and 7. If anybody was in the United States at the time, the real estate markets collapsed. Practically overnight, I had a 14-person team. They all, I had to fire all of my friends. That was really a rough day. And that was kind of the end of my portion of the Earth Elevator story. Now that Earth Elevator story continues, but I have made a decision to not be a part of it. So I'm not going to talk about the Earth Elevator anymore. I'm going to go back to sharing my screen. Okay. So what happened between 2001 when I started, 2007 when the first version of Liftport ended, and 2010 when we shifted gears? Some interesting stuff happened along the way. Sarcasm aside, I actually bet my career and my fortune on building an elevator in the sky. And along the same time, reusable rocketry was happening. Now, in 2001, I would never have guessed that there would be such a thing as reusable rocketry. It was not on my horizon. I didn't see it coming at all. Despite going to X Prize events and seeing something interesting, I was so fixated on my own solution that I did not see these alternate solutions coming together. So when these things started happening, reusable rocketry started happening. Even 20 years later, there's still question marks about the materials. I think eventually someone will solve the material for the Earth Elevator. I think that is actually the easiest part to solve. But when we started, there were only 400 satellites in the sky. And the idea of dodging this, having this elevator, if you move the base, you could dodge these satellites. That seemed pretty hard to do at the time. Now we have 10 times more satellites. We're about to have 10 times even more. So we're going from 400 to 4,000 to 40,000. I don't know how an elevator manages that environment. And then finally, there have been a lot of anti-satellite tests in the last few years. United States, China, Russia, and India have created millions of debris elements. If you're interested, the International Space Elevator Consortium has put out a study. They think they're okay. I'm not going to question them. They think they've got a solution, but I remain skeptical. So that is the end of my Earth Elevator conversation. We are now moving to the real thing that I really love. I've been interested in the moon from a very, very long time. And around 2010, that's a little ahead. Around 2010, a couple people came to me. Jerome Pearson had written a NIAC study, and Dr. Dana Andrews came in, and he talked to me about some stuff, and Charles Radley and Marshall Eubanks, and a couple other people convinced me that an elevator on the moon was viable now with current technology. And you got to remember, I had just come off of working on the Earth Elevator where I was very assured that that was near-term technology. So when people I know and trust come in and say the lunar elevator was viable, I was very skeptical because I had just been burned very badly, both emotionally, psychologically, and deeply financially burned. So I approached this very carefully. Over time, I too became convinced that it was viable technology. And about So from 2010 to 2017, I was working on it. My small team was working on it. We officially restarted the company in 2017 using, by the way, Bitcoin that I just described a little while ago. That was actually the starter capital for restarting Liftport. So I find that pretty amusing. Through a string of relationships, I came to the attention of the guy on the right. He is the chief scientist of U.S. Space Force. I'm very honored to have a challenge coin from him. I know you can't really see that, but this is an honor that was bestowed on me. Dr. Mosier has been a servant to the Air Force and the national defense of the United States for 30 years, specifically focused on advanced technology and space technologies for his whole 30-year career. And I surprised him with some of our conclusions relating to our lunar elevator. So that was a pretty big day for me. And my team. There were 5 of us, and there were 12 of them, and they grilled us for about 2 hours. And then they came back 3 months later, and they said they liked what they saw. So that was a really big deal for us. And then this is now retired 3-star General, Lieutenant General Steve Quast, who is describing some of our conversations as some of the most important conversations in our nation's history. So I'm not going to say that these folks have vetted what we're doing, but they have expressed significant interest in our task. I'm going to skip some of this, but I do want to give you some context. Last year, about this time, the National Space Council came up with a pretty interesting document that focuses the United States in a few key areas. First, commercialization of the moon, but the one that we care about is returning to the moon to stay. And it is a very ambitious and sustainable strategy. I've pulled out a few of kind of more important quotes, but I think everybody in this audience mostly knows that the United States is going back to the moon in a significant way. That has been reinforced by the new Biden administration, and by maintaining the National Space Council and maintaining some of these policies. So we're pretty excited about going back to the moon in a real way, and so my team has really kind of evolved their plans to fit this new reality. You'll note that I highlight some of the pieces in yellow that talk about space stations. We're going to come back to that in a moment. But I think it's pretty exciting that the United States is planning to be a major customer or anchor tenant of space stations and assets on the moon. I think that is powerful language that has lots of ripple effects. So that's kind of the context, right? That's kind of where the world is, where the United States is. And this is where I think we're going kind of, immediately. And I mean immediately, like in the next 14 years, 2035. I think we are going to have a thriving cislunar ionosphere, and the lunar elevator is going to be a key enabler of that. So what does that look like? Well, I think that we're pretty good at launch, communications, and Earth observation. You've heard over the course of the last 2 days that we've had more than 100 launches this last year. I mean, think about that. That's a launch every 3 days somewhere in the world. So I think that us as smart humans, I think we can basically put a checkbox on launch, communications, and Earth observation. I think we know how to do that. We're going to continue to do it, and that allows for the next step of in-space transportation. We know that there are, I think, 4 well-known, well-funded space tug operations. That's probably the next thing on the to-do list. Our Liftport's elevator is the next piece. We're going to talk about that a lot, so I'm not going to go into it right now. There are about 5 well-funded space station programs, not counting the International Space Station and the Chinese Heavenly Palace. So that technology is going to continue to strengthen. Once we've gotten that, and really only after we've mastered those first 4, mining and manufacturing is going to really start to thrive. Once you're able to start pulling resources off of the moon or harvesting resources from in space, the way Gary Coleman's team was talking about earlier this afternoon, once you have that technology, then something interesting is going to start happening. And then if you get to that stage, then the reason I got into space in the first place, the reason I started working on the space elevator in the first place was I want to build space-based solar power systems. I want to power the top 300 cities of the world. If you do that, you can power 40% of the global population. Justin, a few minutes ago, was talking about global footprints or carbon footprints. I think the fastest way to reduce the worldwide carbon footprint is to build space-based solar power. So I want to see those things happen. And I think over the next 14 years, you're going to see this evolve. So these are kind of the big elements there. You're going to have spaceports, you're going to have elevators, you're going to have asset extraction on the moon. I just feel like it feels like a very important time to be in the world, to be in the space field. We, the global ISU community, are doing really big things, and that feels good. I like that. So let's get into our company a bit. So we're not 14 people anymore. We were the first time around. We are 4. There's 2 full-time and 2 part-time people on our team now. Way smaller. I believe that's about to change. I'm pretty excited about how the rest of the summer is going to unfold, but you're going to learn more about that later, I think. We consider ourselves an idea factory, right? From a business perspective, nobody wants to write a really big check for some mythical fantasy of an elevator, far into the future. So we have to be able to show to ourselves, right, to our own checking account, that we can take our ideas, create some intellectual property, take that intellectual property, turn it into products and services, and self-fund our growth. Now, definitely that has worked out pretty well so far, so pretty happy about that. And I think things are going to be expanding. So the areas that we are pretty darn good at, we talked about materials, we talked about robotics earlier, communications, computing, and energy. We're not very good at the biotech side of things. That's an area that we will leave to other people. But the robotics and materials are especially strong at, and we are becoming better at computing. So I already talked about this. Now, start out under NASA, Air Force Space Command, and U.S. Space Force. That's been pretty important to get. Again, I really can't use the word vetted or validated by Space Force, but to have their attention as we are moving forward is very powerful. And it is a network, right? It's a network. ISU is a network. And so our community, the people that are interested and involved in our elevator, this is not a typo. There are 300 folks with masters and PhDs that are pretty actively interested in our program. And it's no exaggeration to say that adds up to 3 millennia of experience. Our larger expanded team, we call that our technical advisory council. They have hardware everywhere, and that to get validation from them with that experience, it makes me think that we're really onto something really extraordinary. So what is this thing? What are we actually doing? The mechanics are very different from the Earth elevator I just described. There's a difference between a centripetal elevator, which is the Earth-based system, and a gravitational elevator. But you're still using the same basic idea. There's a big long string, and you're having a robot climb back and forth. So it kind of, this image is really to showcase the elements. It's important to note, objects not to scale, distances are to scale. So this is what we're really talking about. We launch in a very conventional way. We get out to the Lagrange point. That's the gravitational middle between the two gravitational bodies, the Earth and the Moon. We dock at a space station. We climb down to the surface of the moon, harvest whatever we're going to harvest, come back to the space station, process it, and head back home. Now, obviously, that is a massive oversimplification, but that is the basic gist of it. We're going to talk more about the details here in a moment. When we first started, and thanks to Jerome Pearson, who again he died earlier, late last year. He came up with this idea that it's going to be all about cargo going back and forth from the Lagrange point down to the surface of the moon. So this is kind of the scale that we're talking about. This tiny dot over here in the corner is the moon. It kind of puts the whole thing in perspective, right? The Lagrange point's 50,000 kilometers off of the moon. So we're talking a long ways from the Earth, a very long string, but the longer the string, the larger the counterweight, the more Earth's gravity kind of gently tugs and keeps the string straight. And that's all we're trying to do. We're just trying to have a very flexible ribbon that is attached to the surface of the moon and pulled back through the Lagrange point towards the Earth. So some of the important elements are the anchor station. We will sink into the surface of the moon, and that is probably the most risky single point of failure. Obviously, the ribbon itself is a single point of failure. That one we are concerned about. I don't want to minimize that or trivialize it, but the anchor is the area that we are the most concerned about right now. How do we sink into the moon and stay there is really complicated, far more complicated than we originally anticipated. The lifter. Now you've seen images of our videos of our lifters behind us. The lifter on the moon is going to be a little bit different configuration. Instead of a wide flat ribbon, it's probably a string, a thread. That makes the gripping surfaces on the robot a little bit more complicated. But the gist of it is still there. Now, when we did this image, I don't know, I think it was 2012, maybe 2013, we had all these fantasies about scurrying around the surface of the moon and scooping up assets. We had only just learned that there was a lot of ice, frozen water on the moon. This now seems kind of comical, but at the time we were pretty excited about that. So I have no confidence in our rovers, but I have a lot of confidence in our lifters. Probably going to be solar powered. There's been talk about RTUs. I don't think that that's practical, but that's one of the many questions that we still need to sort out. There's so little frictions, there are the masses are so minor that we think we can get all the energy we're ever going to need just by solar power. So I think that's probably the simplest thing. And if you're building a system this complicated, you want it to be as simple as you can be. Oh, right, the ramp. So when we sink into the surface of the moon, it's a pretty tenuous connection. When we want to get out onto the moon, actually have people, jumping around on the surface, we're going to have a secondary asset, an anchor station. This becomes the first, I would say, usable asset on the moon. It's going to be where the robots dock. It's going to be shelter in the cold nights. There's going to be assets that build up around this thing. It's also important to note that we are going to the lunar equator. I know everybody else wants to go to the South Pole, but from a straight physics perspective, you could draw a line from the center of mass of the moon to the center of mass of the Earth. Your elevator is going to fall along that line, and it's just mathematically simpler to go to the equator. Even if you built an elevator on the North Pole and an elevator on the South Pole, because of the mechanics of the system, those strings would eventually meet and cross because of the gravities of the two bodies. So it's just simpler to just build it at the equator. I'm going to come back to this space station idea. We're going to talk more about that in a minute. I imagine a lot of you recognize Bigelow style modules. Hats off to the artist of this, by the way. It was from a fan in, I think, Austria who created this. So hats off to them. It was such a great rendering. We've used it a lot. But this is a giant space station. And I think it's kind of the beginning of what we'll see in the future. Y'all all know about Delta V. So, Leo, from Earth to Leo, Leo to Geo, Delta V is the price you pay to go to space, right? Look at the Delta V over here. Once you're at the Lagrange point, so it takes all the same energy we always talk about, but once you're at the Lagrange point, the Delta V to get to Mars or anywhere else in the solar system is 0.14, right? So from the ground to Leo is 9, Leo to Geo, let's call it 5. And to go anywhere else in the solar system, once you start at that point, it's basically energetically free. So I think that's something that I find really fascinating. It was one of the main reasons that convinced me that we should actually go after this. I became a big fan of the Pico Gravity Lab at the Earth Moon Lagrange station after I learned this number. Same information on a different slide. We're going to move on. All right, so why does this thing matter? This is a story of change. I'll tell you what we started with, and I'll tell you why we changed it, and then where we ended. So originally, again, back in 2010, no one was talking about going to the moon. No one was talking about going to the moon in any credible way in 2010. Not the United States, not China, certainly not European Space Agency. There was no mention of a moon village. Nobody was seriously considering going to the moon in 2010. Not funded credible programs. So we were looking at it, and the value of the elevator is soft landing. Why aren't anybody going to the moon in 2010? Because it's super, super hard to soft land on the moon. We go to Mars because we have an atmosphere, we can aero brake and gently, even though it takes a lot of bumps, gently land on the moon. On Mars. There was no expectation you could soft land on the moon. So that was kind of our killer app originally. But then again, I got caught off guard by reusable rocketry, right? I've been using this phrase Starship Singularity for a couple months now, with the understanding that a singularity is that point beyond which you cannot make valid predictions. Earlier we talked about blockchain, we've talked about the early days of the internet. There's a point where you can't make valid predictions around space development past the point where Starship is regularly flying. If they really hit their targets of 1,000 or 100, or I think Musk has been talking about 3 launches a day of a Starship, that's 100,000 tons. To put that in perspective, last quarter, the whole 3 months of last quarter, we only launched 240,000 tons. So that's 2.4 launches of Starship. That's not even one full day's production of a Starship is possibly capable of. So if we've got Starship, if we've got a global consensus to go back to the moon, we heard a presentation yesterday that there are 60 planned missions to go to the moon in the next 15 years. I think that number is a little high. I think it's closer to 40. But whether it's not zero, whether it's 30, 40, or 60, it's not zero. So everything is about to change based on new politics, new technology, new capabilities. So with that in mind, we are still going to be able to do soft landing, and I think the dust clouds are going to be created by 30 to 60 landings on the moon. That is going to be a problem that people are not recognizing yet. So I think soft landing is still very, very important. But because of all this activity, because of this new technology, because of more than, I think, 6 reusable rocketry companies in the United States that are flying or near flying. I think they're already flying. And then more than 6 outside the United States. So more than a dozen reusable rocketry companies, more than 150 other rocketry companies in development. When stuff goes to the moon, or when stuff goes to cislunar space or LEO or GEO, there's going to be a lot of activity. And that activity makes us believe that orbital servicing and assembly and manufacturing is going to be super important on stations. There's going to be stations at LEO and GEO. I think there's certainly going to be an enormous space station in the Lagrange points. What makes an Earth-Moon Lagrange 1 point useful, viable, and useful is the string. Because the string is attached to the moon, a station at L1 becomes extremely attractive. So that's kind of what we're doing. Liftport is a business. I want to make sure that this is well understood. We're not seeking capital yet. This is not a pitch. But let's talk about what we're doing, right? The first million proves our math. We still think we have some math to check. The next 4 million, total of 5, build some very essential experiments, some on the ground, some are in satellites. The next 20 million, total of 25, get some of that hardware flown, and we get some results. Now, all of this plan is based around de-risking the next step. 80 million basically, I mean, look at it. Our string is about $30 million, right? We got to put a deposit on that. We've got to put a deposit on a rocket that's going to carry us, right? So that gets us our building blocks. Our 800 million budget is for the entire functioning lunar space elevator infrastructure. Let me reiterate that. 800 million is for a complete functioning, basic, but functioning lunar space elevator infrastructure. That number actually came together in about 2012, I believe. It's probably a lot less than that. It's less than 800 million, but we're sticking with that number because there are still unknowns. When we came up with that number, we thought we were going to have to build our own in-space transportation system, but thanks to Astroscale and Northrop Grumman and Momentus and a couple others, Astra, they've built the in-space tug system, so we don't have to even worry about that. But that's still in our original budget. Also in our original budget, we were expecting to use a Falcon 9. A Falcon Heavy had been announced, but it wasn't even barely off the drawing boards, and there was no such thing as a Starship. So we kept the original numbers for our original rocketry program, but those numbers probably are not justified anymore. So we think it is south of 800 million, but we still use that number because there are always unknowns. And then finally, long down the road, it's probably a couple $2 billion to build out all of the necessary mining systems to build space-based solar power. So that's just, to kind of showcase the steps. I'm going to skip this, but I do want everybody to understand that revenues is really important to our company. We're going to talk about this a little bit more. I want to talk about the parts of this, right? So requirements, architecture, feasibility, and trades. This is not easy, the stuff that we're doing. It's not easy. And I'm somewhat famous for two quotes. The first one, there's a profound difference between difficult, very, very hard, and impossible. I use that as kind of a reality check phrase for myself. And then the other one, which kind of fits here, is we don't even have all the questions, let alone have all the answers. And I think it's really important to state that, when we were a larger team and we had, a pretty big community, we knew a lot more about the Earth elevator than we currently know about the lunar elevator. So that's still something we still, like I said, we have to check our math. Skipping that, these are some of our experiments we're going to have to run. Skipping this, I just talked about this. This is also some of the experiments we have to run. Everybody focuses on the hardware, and I like that they focus on the hardware. I'm a big nerd. I like focusing on the hardware. But if you ignore the business, the outreach, and the framework, if you ignore how do you pay for things, what do you spend your resources on, if you ignore storytelling to your global community, and if you ignore the rules and laws in which we have to live, you're not going to go anywhere. So while it's fun to focus on the hardware, and that's usually what I talk about in these presentations, these other four parts are equally, not subordinate, equally important to me. We talked about risk mitigation. Skipping these things. So this is kind of how our company is structured, how our idea is going to come to fruition, right? There's the idea factory where we invent parts of the future. We use the elevator as the lens to focus our research. Then there are public-private partnerships. We've talked a lot about how government is influential and a catalyst for developing space programs. And then ultimately, we want to build out infrastructure, right? So the Idea Factory has spin-offs, those have exits, we have operating subsidiaries, and we do a lot of licensing. We're definitely focusing on U.S. Space Force as one of our early partners. Surprisingly, even though this idea was initiated under NASA's leadership, it has never really gotten a lot of attention within NASA. So while I'm grateful for them to give us the start that we got, they have not really been interested long-term in our program, which I find a little curious, but I understand where they're coming from. And then finally, you know, the infrastructure that we want to ultimately build, lunar operations, right? And then we get into some of the more, you know, fine-grained details of the technology that we're developing. So that is what I want to talk about. I appreciate everybody's time and attention. I'm going to stop sharing my screen, and I am happy to answer questions. Thank you all very much. Appreciate it. Are you going to unmute, or am I just reading this myself? Okay.
Sorry, I was just doing the share screen. So yeah.
Perfect.
I think orbital debris will be a problem for space elevator operations. Would you consider not anchoring the elevator cable to Earth or the Moon?
Yeah, interesting. So absolutely, I also agree that orbital debris is a big underappreciated problem, both for the Earth elevator especially. It is less of a problem, but not a problem for the lunar system, because we are going to have assets circling the moon. We're going to have more assets circling the moon pretty soon. I am very concerned about orbital debris. I am not sure it is a solvable problem. I'll post a link to the International Space Elevator Consortium. Believes that they have a really good handle on orbital debris. I disagree, but they're very smart folks over there, so read the paper yourself. There is a long-standing idea of a non-anchored elevator. It's often called a skyhook. Fascinating topic. We looked at it really, really early on and decided that it was technologically more feasible. Earlier technology
Hey guys.
Hey, I wanted to do a quick checkup. What technical one? Hold on.
I've been really wanting to chat with people about their how did you get into ISU, what year, what program, and to hear and I went to the same program, so I'm pretending like I don't know that, but I'm asking for the audience.
Christian, do you want to go ahead?
Yeah, so okay, I'll go ahead. So I'm a late converter to space. I joined the Southern Hemisphere SSP here in Adelaide in 2020. So that was the that takes place in January, February, and that was just prior to COVID. Or COVID kind of had already started. We actually had 16 mainland Chinese as part of the program here, and they were all getting worried already from the news that was coming out of China at that time. Yeah, so it was an amazing program, 55 participants, kind of sequestered into this campus of UniSA, University of South Australia, in which is here the summer break. So there's no one else on campus, just us. And as you know, the ISU programs, lots of team building workshops, lots of workshops, model rockets, launched a stratospheric balloon, built, CubeSat, and did the Rube Goldberg workshop, and all these cool things that we remember and we cherish and we love, and what makes ISU so unique.
Awesome to hear.
Absolutely. No, it's a fantastic summary, Christian. And myself, I did the SSP program 08 in Barcelona. That was actually the last time it was hosted in Spain. So it's nice to hear that now there's a trifecta of locations this year. So glad to hear Spain's on that list. And then I had the opportunity to do the Masters of Space Management program in 2009, so following right after that at Strasbourg, France. Fantastic opportunities. I had at both programs, kind of got my let's say my formal space career up and running, and I've been around space for almost 20 years now. It's been quite a journey to date, but ISU took that network and blew it up in ways that I could never even imagine. I still even pick up the phone and call folks even today and for either chat, advice, space or non-space related. So the value of the network, and those of you, of course, alumni and those participating in the programs today, that's one of the huge benefits you get from a program like this, is being able to chat. And for example, like Michael and I worked on a project a few years ago. There's folks in business that I associate with that have gone through my programs or that I've done research with. So it's really something quite fun when you can pick up the phone in any language and even any country and know that someone has shared a similar experience as you have. So quite an opportunity. So thank you again for allowing me to share.
Awesome. Who wants to go first?
Well, I don't really have a whole lot of slides prepared. I can give you a little, as part of introducing myself, also the companies that I work with or associated with in terms of space. Yep. Do you mind if I share? I do have sharing permission. Thank you. Let me just, can you see that slide?
Yes.
Coming up.
Yeah, it's full screen.
Okay, awesome. Thank you. So as I said earlier, I'm a late converter to space, and that is primarily because I've always had an interest, but I never really had a chance on really any engagement with the space industry. My previous career was in venture capital for enterprise software and then B2B SaaS. So some of these companies that are listed there, you might have heard of or seen or something like that. They're pretty big and relevant. Pipedrive, it's like a sales CRM. Detectify is cybersecurity and SaaS, and Hotjar is where you can track what people do on your website in order to improve your website. And then I had a bit of a, a couple of years ago, I was thinking, what do I want to do next? And I was touring around Australia, and I discovered Adelaide, and there was a lot of things going on here. And I had done some work in space before, but not a whole lot. I'd actually seen a couple of space deals from the VC perspective, like Space No, and and found it interesting and had sort of dived into it. And then I had worked with a company that's down here, Space Tech Partners, out of Munich, on one of the consulting studies that they wrote for the EU Commission, the EU government. And again, from a venture capital perspective, how would venture capital need to adopt or adapt to the space tech world? And then I sort of made that decision that I needed to double down on space or not do it at all. And this is when I then decided to join ISU. And this was also about the same time that I decided to do that I was working on a project for the New Zealand Space Agency in one of their grant programs. What they wanted was someone who was not part of this New Zealand space bubble, which is obviously pretty small, and someone from outside, and someone who was more commercial and not technical. And so I was working on that grant program as one of the 4 people assessing the applications. And there's all these acronyms that we love in space that I had literally no idea about. I knew some of the concepts like space debris, etc., but I hadn't really looked deeply into it. So, and this is when I decided, all or nothing. And then I went to ISU, and now I'm an investor with some money through a venture capital fund in companies like Hero Robotics, Alula, Precious Payload, and Endurosat. And Moonshot is an accelerator here in Sydney that I'm part of as a mentor and also small investor. There's actually a Canadian company that's part of that. I'm actually not quite sure whether that's public at this point or not, but they do have a showcase next week. And if you want to sign up to that, that would give you insights into the companies that have been taking part in the Moonshot Space Accelerator in the last couple of weeks and months. And one of them is actually 2 of them are Canadian, 2, and then a couple of Aussie ones. And yeah, so that would be one way of getting to see that. Yeah, so this is sort of my space journey. And I work part-time at a startup support program called Stone and Chalk here in Adelaide, which is general startup supports. Think of it like a co-working space with like a value-added layer, mentor matching, investor matching, and all that. And I sort of run their space activities. And I do that primarily because I get to sit in the building with the Australian Space Agency and a bunch of other space companies. So it's the same building, and it's really cool. So I think Enrico Palermo might have presented yesterday here at the conference. He's an ISU alum, the head of the Australian Space Agency. So I run into him sometimes in that innovation precinct where that is. Yeah, so that's just a quick summary in terms of what I do for space or how I've come to space. Happy to share any further insights. I'm just going to unshare this, okay?
Sure. Well, I'll be asking you more questions about that in a second. Tahir, do you want to jump in?
Certainly. Thank you. So my name is Tahir Morali. I am, as mentioned, based in Canada, but I started my foray into the space world in the human spaceflight sector. So I come from the world of astronaut operations and training. And I started very early in my career. Had the opportunity to work at the European Astronaut Center in Cologne, Germany, as an astronaut instructor. Shortly after, actually immediately after my my time at ISU. And one of those jobs that you might think is, first of all, didn't know existed. Second of all, it ended up being my dream job. So, hey, if I can get that at a very early age, why not? But it was really an interesting opportunity to understand how the space sector really pulls the best skills and talent from all across all different industries. And so in that role, I was working with a multidisciplinary team and an international team from many different countries with multiple backgrounds. Some folks had MBAs, some folks had degrees in astrophysics, some folks were engineers. And so you put all these people together in a team to really take the best and brightest of the points and deliver great product. And so it was amazing to see that happen in this, right in the heart of Europe's space sector. And certainly something that I do cherish and kind of keep with me as a reminder that we are doing, we when I talk about we in the space sector are doing some great things, but building on the successes and the talents from other sectors for us to be really, really, truly successful. And so it's kind of started on the human spaceflight side. I had the opportunity to conduct research both at NASA and at ESA. And then returned to Canada, spent about 7.5 years in the energy sector. So I worked as both an engineer and a project manager on some of the world's largest energy mega projects, both here in Alberta and working with suppliers around the world. But at the same time, I opened up a space consultancy, and so had the opportunity to start understanding the business of space and using my space management background. And that ended up leading me to an opportunity to work with the Canadian Space Agency. So I ended up working as a project management engineer at the CSA, basically involved in both project execution as well as oversight on a number of their portfolio of projects. And so, and providing input into long-term strategy of the organization. And so now seeing the government side, I had now the opportunity to use and understand kind of the industry, academia and government, and kind of package that into one. And so I've now been able to take that experience. Recently, I was part of a startup called 4Pi Lab, a former COO there, and now there's a strategic advisor, basically building a unique technology for early wildfire detection from space with a really unique IP. And it's kind of starting to build taking all these skills and everything I've learned over the years in different experiences to kind of put that in fruition. And so that kind of brings my insight into the fundraising and the VC side of things and the business of space, and really truly understanding now, having participated, for example, in Seraphim's Space Camp Accelerator, and really understanding what investors are looking for from the space side, and deep space, like we're talking about deep tech, deep space investors. Really, truly, what are the key items and things that they're looking for, and what they think will work and not. And as you may or may not know, they recently listed publicly on the London Stock Exchange a series of essentially a trust, which is kind of a portfolio of various companies that they held investments in, which I thought was actually kind of neat. Nice to see that, at least on the European side. I know there's a couple of ETFs on the North American side as well. And then in addition to that, I've a big part of my work that I do is service back to the community. And so I founded a nonprofit organization called the Zenith Canada Pathways Foundation here in Canada, which exists to facilitate senior level mentorship and work placement opportunities with Canadian aerospace companies across Canada. Very similar to the Brooke Owens fellowship model based in the US. We're trying to emulate that here in Canada and really prepare a solid base of talent for a future sustainable Canadian aerospace and space industry in the next 5 years. So we're actually launching our call for applicants later in about 4.5 weeks time in September. And if you'd like more information as a Canadian, please don't hesitate to reach out. Yep, you're muted, Mike.
Oh, that's getting old. Oh, that's getting old. I've been a big fan of Pomerantz and the Brooke Owens program for a long time. So good for you. Good for everybody that you're doing that. Congratulations. The title of this talk, I think, is pretty funny. Where's the money, right? Where is the money? The United States usually is what is showcased in just how much money Silicon Valley is supporting the field, but it's so different in other places. So I'd kind of like y'all to talk about what it's like from your local perspective, if you see any similarities or any differences between the, I loathe the Silicon Valley model for capitalization, right? I mean, it's so different from what, Christian, you experienced for software. So share a little bit about kind of localization, if there's nuance there. And Christian, I'd like you to especially jump into the difference between investing in a space company versus investing in a ones and zeros company.
Yeah. Oh, yeah. There's so much to unpack. I think the probably the most important of all aspects to this is that Silicon Valley has been going on for decades, and it was actually, as probably most of you know, built on military or government contracts in a lot of things that were hardware related. And then in the last, let's say, 20 years, it's been predominantly software, and whether consumer or enterprise software. And now it's sort of, in the last maybe 5 years, been sort of flipping back to what you could call deep tech and hardware related stuff. Not always Silicon Valley. It's also another phenomenon is that it's sort of spread out all over the US. It's not so much centered anymore there, but it's still probably where you have the deepest pool of money, the deepest pool of talent, etc. And that is something that no other region or country in the world has, that kind of depth and breadth. Now, many other places are catching up, and they're catching up really fast though. So Europe has, in terms of growth, and also Asia is outpaced the US in terms of venture capital growth, but obviously from a much lower base. And we do have, in Europe particularly, always had a strong culture of founders, sort of, or a strong element where companies coming with some sort of university or science or research background. They haven't done it particularly well, but there's always been an element to that. And now with a lot of European founders having raised money successfully and had successful exits in the past 5 years, actually more like in the last 2 or 3 years, there is now sort of where that loops back into all other verticals, including also space tech. So you do have, a private launch vehicle companies, startups, basically building rockets, that have raised now $100 million or more dollars. So that's happening. Similar in Asia Pacific, or specifically Australia, that's also happening, just again on a lower level, just because the numbers aren't there in terms of number of people. Australia has 25 million population. So we do have a couple space venture-backed companies here. They are, however, it's very much concentrated where the capital goes. So about $100 million Australian dollars, which it doesn't matter, right? It's like divided by 1.2 or something, is US. You have about probably 85% or 85 million of that has gone to like 5 companies. And then there is another long tail of, actually it's not a long tail, it's another 10 companies that have raised some money. And then there's a long tail of companies that either have raised no money, or it's like tiny seed amounts, and maybe matched funding for a grant or something like that. So this is where it then sort of falls apart. And these companies that have raised all that money are now about 5 years old. And they're either IoT constellations, or one company actually also building a small launch vehicle. And they're the ones that have sort of got that traction. And now we need to build that second generation of companies that can raise more money, more than $1 million, where whatever that mental threshold is for fundraising success. And so that's a bit what's happening here. Again, it's all though related, though, that whole deep tech thing that people are a bit tired of general software, even though it's kind of predictable and you have a lot of metrics that you can look at all the various fundraising stages. With deep tech, obviously the thing is that you don't have that, and you need to look at other things like TRL levels and interim monetization strategies and these kind of things. Personally, I'm more comfortable looking at companies that are software only, because for obvious reasons in my past and not being a technologist and or scientist, but I am getting more comfortable with it over time now that I've spent 2 years looking at space startups, but I'm still due to make a real hardware investment.
I'm going to just jump in and tell a quick story. So during the first version of Liftport that I just described, back in 2003, 4, 5, 6, and 7, we were self-funded. It was funded primarily from my own checking account, not exclusively, but primarily from my own checking account. And I would see companies raising $500,000 on a napkin sketch pitch, right, as Silicon Valley, because all they were doing was hiring a couple engineers from Stanford, feeding them pizza for 6 months, and then they'd have a product. Whereas I was looking at buying a microscope for nanotech. It was $400,000 for the machine. That's not anybody to run the machine, right? So it's a different animal trying to invest in deep tech versus trying to invest in ones and zeros. So both of you have used the phrase deep tech. I want I want you to kind of dive into that a little bit. Let's get some definitions. Like, what does that mean to invest in deep tech? What does it mean to invest in space?
Absolutely. So I think there's a way of framing, if you come in investors or let's say non-traditional space investors and talk about space tech investment, the first thing they think of, huge capex, capital expense. It's long-term ROIs, 7+10 years. Not my cup of tea. Most investors would probably balk at that because they're the ones that probably want the 6-month, 8-month, 2-3 year returns, right? And so reframing that in deep tech kind of just includes not only space and space tech, but also other attributes. For example, investments in the AI space, right, or in the like kind of the data processing kind of areas, right, where it's like, okay, there's using technologies in different fashions, sometimes even health, there's also health tech, but some of that I would include in that too, because there's a lot of hardware and software developments on that end. But really trying to categorize investments in facilitating technologies towards a solution rather than just one hardware or one software solution, kind of a hybrid. And so that's something, that's one way to look at it. Another way to look at it is, okay, well, we in some of my past pitches, we took kind of the clean tech and envirotech route. So we're saying, okay, well, yeah, we're not coming at this as we're the space company. We're coming at this as we're a data company, right? And at the end of the day, we're providing data to achieve solutions to for wildfire mitigation and therefore climate, in support of climate and environmental change. So okay, well, you look at that kind of clean tech and envirotech side of things, we would be the only space company out there in those types of those fora. And so it's just a mentality shift where just because you're classified as, or you think you classify yourself as a space company because you're doing space stuff, doesn't necessarily mean you don't apply to other domains where you can use space solutions and space services, space data, space hardware, and apply that to others. And I know ISU actually really teaches us that, of saying, look, like, it's all about space applications and applying what you can get. It's one thing to put the satellites up there and build the rockets to do it. It's another thing then, and in my mind, perhaps more lucrative side now and in the future, is those applications and the downstream impacts that hardware in space is going to deliver for those on the ground. And so I found perhaps more so like 2 or 3 years ago was still more of an education about that shift. I'm seeing it now as people are starting to both investors and those seeking to get the money from the investors are now understanding that there are more capabilities out there, and they've kind of started to shift their mentality a little bit. So that's kind of what I would kind of answer that deep tech question. Mute. It happens.
Can you guys see?
You need a headset like mine. You just put that thing up and down. It works really well.
I don't know if y'all can see on the camera, but I just roll my eyes whenever I do that because it's just so aggravating. I've been on screen probably 10 hours of the last 25. So I've just been doing it. Sorry. I know the Moonshot program where you are, Christian. Tahir, I got my location wrong for you. So are you familiar with the Creative Destruction Lab program in Toronto? Yeah, okay.
Yep.
So in both of those cases, and this is from an outsider's perspective, I had considered applying for both of those with my project. I called them up and I talked to both people at both of those programs, and it was pretty obvious to me that they were interested in data plays, not interested in the hardware that supported the data. Is that your experience? Is that true? Has that changed? And my information on both of these is 9 months to 6 months old. Are they mostly focused on data, or are there hardware elements also?
Yeah, good question. So I can't speak for CDL, Creative Destruction Lab.
Right.
I've heard of it. I actually know a company that took part in it, Precious Payload, but I don't know more than that really. For Moonshot, I can speak a little bit. One company that is taking part is very heavy on hardware. The others are less. They are, I wouldn't call it data plays, but they're more about actually one is, which is called Alula, which is basically aggregation of Earth observation imagery and data and distribution, focused more on distribution. And the other one is more power in space. And
Christian, you faded out for like 10 seconds. You said one was data. What was the other one?
The other one was virtualization of existing assets in space.
Sorry, I don't know what that means. Virtualization of existing assets in space.
Yeah, I know. I'm trying to dance around the fact that I don't know whether
okay,
all these companies have been disclosed.
But I might, yeah. But I think perhaps maybe the most recent cohort of the CDL might be more focused on data, because they've had some pretty significant investments and successes from companies past that have been both hardware and software companies. So not just on the data side, but also investing in the hardware. Like for example, Kepler Communications is one that's based in Toronto, who was kind of one of the early companies that went into through the CDL program, and has been very successful, and just recently closed. I think it was a $60 million round, if I'm not mistaken. So they've certainly benefited. I know. So the company I'm affiliated with, 4Pi Lab, did go through the program. I wasn't part of that at that time, but there certainly was benefit as graduating as a company from that program, especially because we were both hardware and software again. I think it might just be the way that the cohort may have shaked out this time around, but certainly I do know that the CDL space is specifically based in Toronto, so the space stream. But to my earlier point, there are other streams out there that could engage space companies depending on their stream. So they've got like CDL Rockies here, which predominantly has kind of an energy and environmental flavor. There's CDL Wisconsin, which is more on like an insurance and risk. So there's a number of different CDLs spotted across the globe, depending on the stream and theme of the content that you're seeking. So again, you're a space company out there and you've got a great idea that will say reduce risk and apply to insurance, and that might be a route for you to be able to get to know that market better and make your inroads that way, even if you're the only space company there. So they do have kind of different categories, and of course there's the space one in Toronto, which focuses on, of course, space related or space driven solutions, I suppose. But yeah, like I said, I wouldn't write them off, but I think there's certainly a lot of opportunity through those types of programs. And if for those of you out there that haven't gone through an accelerator or an incubator program, especially like I know, for example, the Seraphim Space Camp was 10 weeks of intense learning. Like if you think the SSP is tough, well, yeah, hey, some of these accelerators are as grueling, but it really chisels you, really shapes you, really understands, like you get to know yourself a bit better as well after some of those programs. So highly recommended for those that are kind of in the early stages, early seed stages of their programs and their companies.
That was my very next question, was to talk about accelerators and incubators. So Christian, do you have anything to add about accelerators?
No, I absolutely agree. I think it's a valuable experience for anyone. Even if you're an accomplished founder, it still makes sense to join an accelerator. But especially if you're a first-time founder, I think it makes a lot of sense. It is a bit of a tricky situation though, because so first of all, there's two things, right? You want to pick like the best accelerators, and it's really hard to get into them. So you might have to work your way up by going through another accelerator first, sharpen your skills, your story, your pitch, etc. And then, maybe a year later, go for that next level accelerator. Like CDL is like a tier 1 accelerator. That though, it takes a lot of time. It might be considered a distraction, etc. So that's the one tricky thing, and the other is there's a lot of stuff globally now slushing around with like virtual participation, and that is it can work, but you need to dedicate a lot of time to it in order to gain that value add. For Moonshot, we did virtualize it because of COVID and no one can come to Australia. And it has worked, but I know that especially on Troy, who runs Moonshot, it's been really, really hard in terms of just the commitment and the time, etc. It's also because we're completely self-funded. We don't have any government money. We now have some government money, but it came after the program basically now already finished. And so he's put a lot of time into this with the help of the mentors, etc. But it was definitely not easy. But yeah.
Full disclosure, I submitted Liftport through CDL last year, and then talked to them about why we were declined about 6 months ago. The CDL application process closed yesterday, and I made the decision not to submit. I was very interested in submitting to Moonshot, but I did not want to do the program virtually. So I think we probably fit the Moonshot model a little bit better, but I'm just going to wait till the world gets a little more healthy, and then I'll submit. But I don't want to like have this conversation with false. I'm a pretty transparent guy, so just
no, that's cool. Yeah. Honestly, it's really hard to pick out sometimes why people don't make it into a certain accelerator or VC funding. It's really hard because I've been on the other side for years, and I know of sometimes random decisions just because they don't fit for some reason. And sometimes it turned out to be wrong. I've been wrong. Like people became successful. Sort of, I think Bessemer Venture Partners calls it the anti-portfolio, the companies that you had a shot at investing in, but you didn't invest, and they became successful. That's important, right? Because of companies, a lot of companies you never hear from again, but then they're the ones that you actually had a shot of investing. Like Facebook is not my anti-portfolio because I never had a shot at investing, but there are other companies like that are pretty large and relevant now that I had a shot at investing and I didn't. I made a conscious decision not to invest or not to recommend it to my team or whatever, take it forward. And then, so that's anti-portfolio, and that's very unfortunate. But then again, you say 99 times no per day, and that's just it's just the way it is. And I think in space or in deep tech general, a lot of investors, first of all, they're relatively new to it, so they haven't calibrated their skills and their judgment. The other thing is very often what people look for is some sort of interim monetization strategy by the company. So sort of the big vision is here, it takes 10 years, but we can't get your money for 10 years in order for us to just burn it through over time. Therefore, we have this strategy to do X, Y, and Z in the meantime that also gets us some money and is not completely that's something that's different. It's something that helps us on the path and makes some money, even though it might make it slower or it might be a little circuitous way, but it does in the end provide for some interim revenue. And that is something that obviously if you're trying to build something as a Liftport structure, I honestly, I wouldn't know. So that's why I defer to smarter people.
But to your point, Christian, that calibration of knowledge and judgment is absolutely correct. Like investors will invest if they're comfortable and that if they know the space that they're going into, no pun intended, they know the space they're going into and the kind of the fora that they're playing in. And so it's, we've had some challenges, walking into some meetings where space is no knowledge with some. So how do you like your pitch has to be both the pitch and an education about the value of that sector and that space, and sometimes it works out because they appreciate that, right? And other times it's just from the get-go, if they're not really upfront and comfortable with the content in that space, you're hard pressed to try and climb that mountain, right? So yeah,
I actually have an example that just occurs to me. If you don't mind, if I share that example of this like interim monetization strategy. And full disclosure, it's one of the logos that you saw earlier on my introduction slide. So I'm a small investor in that company. It's called HEO Robotics. They're from Sydney. You can Google them, HEO Robotics. And basically what they do is they use in orbit Earth imaging satellites in order to take images of other satellites. So they basically try to find a supplier satellite and match them with a customer satellite that wants its image taken, figure out the trajectories, and then the secret sauces in the software of doing this, take an image of the customer satellite using the supplier satellite, with cameras that are optimized for whatever, 500, 600, 700 kilometers, and all of a sudden that satellite is only 70 kilometers away or whatever. So by order of magnitude improving that the usage of that camera in idle time, whenever they're flying over oceans or whatever, and these kind of things. So you can use that for a lot of things. In orbit inspection, you can use it for like 100 reasons why someone would want an image of their satellite, right? So the point is, it sounds awesome. It sounds really smart and also very asset light model, right? The thing is, it's actually sort of an interim monetization strategy, because what the real ambition is to do this for asteroids, basically fly up to asteroids, near Earth objects, and then sort of map these asteroids with hyperspectral imagery in order to figure out what these asteroids contain, and then map them. And that is something that's much further away. But if you went to an investor and said, we want to inspect asteroids, everyone would look at you and say, that's just crazy, right? But if you tell them, hey, we're testing our software already, and we're testing all this in the meantime, right? And we can take this to GEO, where there's really expensive satellites, and it's really much more important also to have sort of inspection of your assets, right? Because you have billion-dollar satellites with $10 billion lifetime value, whereas in LEO, that's again by magnitudes different, smaller. So long story short, the big story is so far away that they started with a small story, and people liked it because they were making money. It worked. They could show traction. Even Australian Defence is a customer. So hey, that's a story, and so they were successful in that.
Yeah. Imagine trying to walk into a room trying to tell people you're trying to build an elevator in space. just imagine.
I don't have to imagine. Yeah. I've seen some, right? But that's okay. You gotta try. And I think one of the things I'm curious to know your guys' thoughts on, actually, if I may ask a question to the panel.
Can you just
go ahead.
Hold 1 sec. Christian, I flashed this challenge coin from the chief scientist. That guy wants to know about your client's software. I'm just telling you, that's a conversation that I can make an introduction for.
Okay.
Yeah. Sure. So go ahead, Tahir.
No, this is awesome. So one thing I'm always very curious about, especially in the space domain, is if you look at a company like Relativity Space, right, where they didn't come across as a space company, they came across as a technology company, using 3D printing, of course, to design their rockets. And so in 2016, 3D printing was just taking off, and I got this, a sample from 3D printed metal sample of the Orion capsule back then, about what the capabilities would be about metal fabrication with regards to 3DP. And so you look at a company like that who, their investors are not traditional space investors at all. It's something like Fidelity Investments, right? Like it's investors that are really looking at the use of technology to achieve the objective, rather than, okay, you're a space company trying to build rockets for propulsion and bring down cost of market. Okay, that's where they're going. So from that perspective, though, something like, if you look at a company like Relativity, how do you think they might pitch themselves to those investors that, as I mentioned before, perhaps have no idea about the space that they're operating?
I know one of their professors, a guy named Dr. Greg Autry. So he was their professor when they were first getting started. And it was a materials play from day one. It was not about the rockets. It was not about, they said, we can point blank fail and never light a rocket ever, but we are going to be so good with our materials science that we can shift to building any complex system, right? We can build better refrigerators. We can build better, look at how complicated a rocket engine and a rocket nozzle is, right? If you can do that, you can make a better refrigerator. You can make a better internal combustion engine. You can make a better blank, blank, blank. So they were prepared to fail from day one on their big idea because it was a material sciences play. And frankly, I think that's kind of genius. So hats off to them for that one. Yeah. Yep. Let's talk about Christian. You talked about the portfolio you didn't make. What would you call it? Your negative portfolio?
Anti-portfolio.
Anti-portfolio. Yeah.
I love that. I like
that. I had about a 15-minute conversation with Steve Jurvetson. He's one of the earliest Silicon Valley giants. And it was actually a really just chill conversation at a space conference, and I wasn't pitching. I wasn't like a fanboy. I had a legit question, and I saw him in the hallway, and he was very approachable. I said, why SpaceX? I mean, it's not your normal investment. That's not your normal investment profile. When you made that investment, it was a ridiculous long shot. So why did you do that? It didn't make any sense at the time, right? It's easy to look back, but it's hard to look forward. And he said one word. He said, regret. I'm like, what do you mean? He's like, we had a chance to invest in PayPal and we didn't. We were not going to miss the next thing that kid did. And so it had nothing whatsoever to do with space. It had nothing whatsoever to do with, Jurvetson was not a space nerd before. He has become a pretty world-class space nerd with a super interesting office. But it was regret. So so what have you done that you missed? What were the things that you're like, maybe I said in my last presentation that I sold Bitcoin at 900. So that was one that I missed. So what's something that you didn't see? What was something that wasn't on your radar that you've been surprised at? I know both of you are kind of new at this investment game, so I don't expect you to go back in history very much. But what's something that's been surprising that you weren't paying attention to?
Well, that's different from anti-portfolio, right?
Yeah, I know.
Anti-portfolio is deals you saw. Then
I
there's a bunch of deals
want to put you
or industries I didn't. So I'm not a huge crypto guy. I totally admit that. It was never something that spoke to me. It was never something that I really got into. I can see from a very, very high level view why it's relevant in terms of decentralized everything, which I'm otherwise a huge fan of, but I never got my head around Bitcoin. So that's something where now, like sort of 10 years in, I feel like pretty embarrassed, but it's just the way it is. With the anti-portfolio, it's actually it's quite a touchy subject because it goes deep into one's also success or performance as a venture capitalist, and very few talk about it. I'm one of them, and best of my venture partners is, but it's very easy when you're like a top tier VC to talk about it, because you can say, oh yeah, we missed an investment in Google, yeah, and otherwise you're like a outperforming fund, outperforming everything and everyone, right? But and then it's easy to talk about how you missed investing into Google because you didn't want to talk to two students in a Stanford garage. So for me, there's actually one company which many of you might have heard of. So I actually saw a pitch for DeepMind. And DeepMind is one of the early sort of AI companies. It was acquired by Google for, I can't remember exactly, around about $300 or $400 million, but they had only raised like 10 or 15 maybe. And this is about maybe 4 or 5 years back.
They were the ones that were doing the interpretive images, where it would create an AI generated image of something. Yeah. Okay. That's cool.
Yeah. So but it's always important to see the circumstances of that. And the circumstance in that particular case was that we had looked at a few AI companies, pure play AI, so not like applied to anything particular in an industry or anything. And the big tech companies had just gobbled up a bunch of AI companies. So we were like, oh, well, that ship sailed. The other thing being that the way it was presented to us, it came through like a lawyer. It was a one-page write-up, and it was basically a very narrow written, like the way lawyers write, summary of, this, I think it was Cambridge or either Oxford or one of those two based companies that, had this amazing AI, but it's still a long way to go till they have any revenue, and they had raised $7 million before, and that was it, and that was literally the pitch, and I took it into a meeting, and we were like, oh no. And then it turns out that one of the partners was actually an AI expert, wasn't in that meeting, and that was a mistake. So there was others. There's a company out of Eastern Europe called Bolt that is an Uber play, and they raised their first money when Uber was literally raising, this is also like 5-6 years ago, was raising like $1 billion every quarter. And so I got their pitch, and I was like, no chance, right? And 5 years later, these guys are running really well. They had a different strategy. They compensated differently. They went to all the second-tier countries in the world, second-tier cities, and they're $1 billion unicorn now. And
Nice.
So there's always room for followers. And when you think that the market is taken, the market is full, it's crowded, actually it just keeps growing.
No, that's the value of innovators, right? They're going to come by and say, okay, well, there's a niche, but there's a niche within that niche that I'm going to go after. So
yeah,
and to that point about kind of your earlier point of kind of the interim funding plan to get yourself to the bigger goal. I'm part of an international working group with the Moon Village Association that's developing a working group. There's a working group related to lunar commerce, and how do we build out the econosphere with regards to the lunar econosphere, and what does that look like? How can companies today that are seeking to do the 15 years from now go out to those investors to say, hey, let's, where are the papers? Where's the documentation? Where's the knowledge? Where's the investigation? We don't have a lot of that, right? And so this great brain trust, and I'm not taking any credit for this because I haven't actually been as engaged with it as I would have liked. But the premise is that, producing a document that would say, okay, well, here's kind of 9 different market areas to consider of what a lunar supply chain might look like. What are the things and pieces that have to be in place to support that? So yes, great, all good if you've got the propulsion to get yourself there and the rocket and the lander to get you down. But then what? right? What are the next steps to ensure that you've got the communication links in place, that you have the understanding of the, whether or not it's the valuation of the product you're seeking to extract, where that product might be located, supporting perhaps human operations on the surface. There's a number of different considerations that are in different pieces and different groups around the world are working on. But there's no real kind of centralized effort to say, okay, well, let's figure it out, right? And so it's an interesting opportunity there that's in the development. But with regards to regrets, for me, it's 3D printing. I think, as I mentioned, I was studying it very deeply in 2015, 2016 in my work for a Fortune 500 company, and took a year studying that market and understanding. I could see where it was going, but I didn't do anything about it. And so that's why I brought up the relativity piece. It's like, geez, guys, I know how long they've been working on that, and the fact that they're doing that now literally is blowing away even construction and a bunch of different markets that are leveraging some of these technologies. So it's for me, it's 3D printing, but not necessarily space related. And then I did have another opportunity, through kind of a very early, I guess it was pre-seed or seed round to invest with a company in Canada, which I didn't, which has gone on to be very successful. And so it's one of those things where, you make your choices, you do what you can at the times with the information you have and the knowledge at your disposal. And, you make your calls and, you live with it and you move on. And that's why the classic, if you get the one unicorn out of the 50 no's you gave, you still at least got the one unicorn. But yeah, certainly there's lots of space to play in. Absolutely.
Well, so I'm going to flip that around and say, all right, what are you paying attention to now? What are you eyeing that's like, oh, I like this one? Are you still with 3D printing, or is there something else that's got your attention?
I still keep my eye on it. It's not as much as I was before, but certainly is something to know how things can be done on a mass scale. Like, having worked in some industries, so for example, like energy and automotive, where mass production and batch production is more common. But to be fair, satellites are getting there now, so I guess we can include that in there too. And rockets. It's for me, I think it's more focusing on optimizing those processes and really ensuring from a let's say an operations research perspective, how can we make that more efficient? There's lots of lessons learned from the automotive sector and building that into manufacturing and line manufacturing, but seeing kind of, at least on the propulsion side, a number of these companies follow the same methodology as each other. Of course, there's you build airplanes, it's the same kind of rudimentary way of building them. You build rockets, the same way of building them, right? Seeing where the optimization will come from to get quicker value to the investor. So I think that's kind of where I'm kind of focusing my understanding on, whether that's operations research, human-wise, or AI, or leveraging a combination of both to understand where the next kind of efficiencies are. That's kind of got what I have my eye on a little bit.
I've always kind of broken. I've kind of created a hierarchy saying that space is kind of a pinnacle technology, and that you have to have mastery of biotech, energy, communications, robotics, materials, and computing before you can do anything in space, right? That those other 6 technologies are subordinate. So I, given my background in elevators, materials and robotics are really important to me. I think that we cannot go to the moon without a really good understanding about sealants and filters. And I mean, it's not very sexy, but boy, is it's the difference of life and death here. There are not any questions from the audience. I've been checking, so we've posted a couple times about it, so I've just kind of kept going with this. But is there? Let's switch gears for just a moment, right? That SPAC, special purpose acquisition companies, have been super popular. I've made the argument that they are the Netscape moment. It's not as big, it's not as obvious, it's not as defined. the way Netscape Moment was, but collectively, if you start liquidating a whole lot of capital that was trapped in equity, I feel like that is collectively maybe not a Netscape moment, but a Netscape year. Do you have any thoughts on that from as people who deploy capital that don't want it to sit there forever and ever and ever? What do you think about this liquidation process?
Just when you say Netscape moment, what do you mean by that?
Well, there was that spot in the earliest days of the internet where it was proven that you could exit from an early .com play. So whether it was Yahoo, whether it was Alta Vista that doesn't exist anymore, whether it was whatever it was, there was a moment, even AOL, whatever it was. People could make investments into very risky ones and zeros companies, .com companies, and then they could exit. Well, so here we are, fast forward 25 years, people are investing into hyper risky space companies, and then they're getting exits, and they're nice exits, they're big exits. So whether they're special purpose acquisitions or whether they're roll-ups, the way Redwire is, the way Tethers Unlimited was acquired, it is not a Netscape moment. It's not a point in history that you could say this happened and then everything else changed after. But it is a year where people are exiting really risky.
Yeah.
Points. So what do
Yeah.
you think of that?
It's the thing with these moments is that you only know in hindsight whether it was that kind of Netscape moment or whether it will go down in history as just the weirdest year ever, where a bunch of privately held companies went public that had absolutely no revenue and were still on a mission that would take years to show any kind of result. And the public markets typically weren't made for that kind of companies. Public markets are made for companies that need to be really transparent about their revenue and how they're acquiring it, or everything basically about them, and that would be scrutinized every quarter, or actually every day and every moment, but especially every quarter with the earnings season, etc., being published. And if you can't do that, and you need to keep selling the vision, at some point, typically, again, investors wouldn't believe that anymore. At some point. And now we're in a moment where all these privately held companies that were privately held for a reason, which is exactly that they need to keep all that not secret. It's just from the public scrutiny that questions everything every day, all the time, with really high, relentless pressure, right? Is that they would now take this public. And I'm actually, I have a couple shares in Virgin and this and that, but it's just, it's just play money for me. It's just really something where I would really not, if I was an institutional investor, I wouldn't invest into that. But then again, maybe, completely wrong. And looking back 5 years from now, we could say this was the wisest moment ever for people to invest. So venture capital as a model.
No, please go ahead.
I mean, venture capital was for a reason, or is for a reason, a bit of a secretive industry in terms of the companies that they invest in, and not disclosing anything about them unless they want to go public at some point, which is exactly what it's called, go public, right? Because before that, it's all private, and private means we don't really talk about our revenue. We don't talk about our margin structure. We don't talk about our strategy because it's something that could change at any time, and we don't want to be accountable to the public about it, because they wouldn't understand it. And so that is sort of the whole thing. Frankly, I don't have an opinion. I think I observe it, I read about it. If I had more money, I would probably deploy more money into it from that perspective. But I'm an early stage investor. I'm a very long term. I don't want to have to look at the markets every day. It's just not me, and so therefore I just leave it to other people.
Right, right. I went on record saying that when Branson was still in control, was it, gosh, almost 2 years ago, 18 months ago, I said, this seems really weird. It seemed really peculiar to me. And, you know, I was a finance professional a long time ago, back in the early 90s. So, I mean, the rules are different now, but it seemed really peculiar. And then to have all of these copycat companies, I do like some of the roll-ups, like Redwire acquiring Made in Space, like some of that stuff making sense. Yeah, I could see that. They're still private. They've got plans. I don't know what's going to happen there, but the special purpose acquisition companies, I still remain a bit leery about. All right, y'all. That was the end of our session. Thank you very much. I really appreciate y'all being here. Your insight and wisdom is very useful to us. The world is changing, and you know, it would be nice to have a crystal ball. And you two are kind of paid to have a crystal ball. So thank you for sharing your insight. All right. Okay.
Awesome.
For the opportunity.
I'm going to pass it on
yeah.
to Mona. Thank you very much, y'all. I'll see y'all there. Mona, it's your screen.
Have a good day.
Thank you, Michael. Yes,
Bye.
Thank you very much, Michael. So hi, everyone. It's a very different session now. We're talking about space medicine, and it would be both me and Susan Joel talking. So I would go first, and Susan follows me. She would be talking about the training of space medics, and I would be talking about more about systematic reviews. Before I start, can I just ask, how many of people are familiar with the concept of systematic reviews? Yes, no. If people have put it in the chat or put their hands up, whichever I prefer, just so that I know I'm going with the presentation.
Can you repeat that? Familiar with
Are you
what? Sorry.
Concept of systematic reviews? Okay, no, that's a good thing, because I've prepared assuming that people are less familiar with the concept, so that we're aware. Okay, so thank you. So I just share the screen. So okay. So I will be talking for 20 minutes, and we would have it open for question and answer, and then followed by me with Susan. So I'm Mona Nasser. I am associate professor in evidence-based dentistry, University of Plymouth. I am a methodologist, so I work in clinical epidemiology and systematic reviews, and my interest is about how we can synthesize data to inform policy and practice. I work with a team that involves people in ESA, in Berlin Institute of Health, and in University of Plymouth. We work on trying to answer different space medicine questions using systematic reviews. I make jokingly say this is my way. I want to be the Sherlock Holmes of clinical data. And similar to thinking about Sherlock Holmes, like in this presentation, I talk about how we have to adapt May's Sherlock Holmes finds out about the murder for space medicine, but I wouldn't tell you about whether the murder happened or not, or who murdered who, because so I wouldn't be talking about what works in space medicine, like what treatment works and what doesn't work. I'm talking about how we had to change how we approach synthesizing data together. And do feel free, if you have questions, to also interrupt me. We would have questions at the end, but I'm happy to answer it. So this work is built up. We did a series of systematic reviews in collaboration with European Space Agency, and as we were doing it, we realized we have to do some methodological adaptations, which is what I'm talking about today. 4 of them are published, 2 of them are ongoing, but the ones that are ongoing, we have them on open science forums. So a lot of the issues that we are trying to develop, people can still use them and go online and use the material even before we get it published. So what are systematic reviews? Systematic reviews are a way that we collate evidence to answer a specific question in a way that minimizes bias. In the old times when I was giving this presentation, sometimes people said, but we always systematically review literature before doing research. One of the things you will see in this presentation about what a systematic review is, and if you work in that area, you see what happens in science. a lot of times when people think they have done a comprehensive review of the literature, they actually didn't do it, or have not recognized how their own prejudices, biases, or methods have affected how the data was selected and why they came up in a bit of biased response to it. So why we're doing systematic reviews, as I said, is to reduce bias and error. It also gives you, the statistical tools we use in systematic reviews can give you a more generalized results about research, because if you do research, you're doing it like in the UK, in US, in the older population, the younger population, but with the systematic reviews, you synthesize all of the data together, so you have a more generalizable result. It helps you to structure the evidence base and identify research gaps, and facilitates evidence-based decision making. One of the things I should say is that one of the things that people disappoint people with systematic reviews, that in a lot of cases you find out that what you think you know, you don't know. So a lot of intervention you see everyday medics use, you do a systematic review and you realize there's actually a lot of open questions here about the quality and the effectiveness of the intervention that sometimes gets missed. So the steps of a systematic review involves you have to formulate a question, very obvious. We do a search strategy, but we do a very systematic approach to setting search strategy. We have a systematic approach about how we screen results. It's not ever done by one person, so one person's bias doesn't affect the results. We screen them, we data extract them, and we analyze the data, and we develop recommendations based on those data. And it's not only based on the quantitative of the data, but also about the quality of the data and how it reflects in it. To give you an example of how a systematic review works, you would have a structured question like this. You would say, okay, in this population, we want to compare this intervention to this, and these are the outcomes we care about. We identify all of the electronic databases and non-electronic or other type of sources we want to search the literature. We develop a systematic search strategy. This is quite long, but lots of search them, but it's defined in a way that somebody else can replicate it. We would, in this case, I took a systematic review that's already done. They had like over 10,000 results. 2 people went through the 10,000 results, decided was included, excluded. All of the included studies were data extracted and quality assessed. And if the data was homogeneous enough to be analyzed, they analyzed it. And then they formulated the recommendation based on the synthesized design and the quality of the data. So, and then they identified research gaps. And how the synthesized data usually looks like is something like that. We call it a forest plot. There are other ways to do it, like with animal studies, we use timber plots. There are different ways to do it, but there are visual ways to demonstrate the data. I should also warn people, I sometimes talk fast. If I do too, please unmute yourself or put a chat that I'm talking too fast. Just before I go to the space medicine one, I just wanted to show the examples of historical examples when systematic reviews people recognize how important they are. Zizian Chalmers is one of the pioneers of evidence-based healthcare, and actually how it started, he started the initiative, one of the key initiatives in evidence-based testing is just the Cochrane collaboration. It started with that he was working as a WHO doctor in Palestine, and he had patients, the children with measles, and there was a question whether he should give them antibiotic prophylactically. He learned in medical school he shouldn't be giving them, but then he realized that there were lots of randomized controlled trials and never anybody synthesized. And if you synthesize, it shows that it's enough evidence to give that to the patient. So a lot of patients have increased mortality and morbidity because nobody synthesizes data together in a way that can inform policy and practice. Another example which actually shapes the logo of this collaboration, which is Cochrane, the logo here, it's a forest plot in it, was giving mothers corticosteroid when they have premature birth would accelerate the fetal lung maturation. If you look at the individual studies, there's too small to show an effect. When we synthesized them together, I wasn't involved myself, the Cochrane people were involved, it was before my time. Suddenly they could have enough evidence they showed effect. So it has been very important to change the practice in healthcare. So what adaptation we had to do in the reviews we talked about, we came up with different ways of thinking with prioritizing outcome measures. We had to identify new databases to search. We had to think about generalizability because we're dealing with studies that are not directly relevant, they're directly not done on astronauts. we had to develop new quality assessment tool, and we had to use a machine learning algorithm for the searches. I go in detail for each option. So first one, prioritizing outcomes. So one of the things that really surprised me the first time I did a systematic review with ESA is that how much of the outcome measurements they use is biomedical and physiological. Like we were doing, the first review we were doing is about rehabilitation of astronauts after they come back on space. My assumption was the first thing you would measure is how long it takes the person goes back to performance. But most of the outcomes they asked us were like physiological and biomedical. And it's because there are different people involved in the health of an astronaut. So it's the astronaut himself, the flight surgeons, the scientists. So what we did, we thought, okay, we kind of come up with a way to kind of bring all of these people together and prioritize which one it is, and then prioritize our outcome based on that. That was very important for one of our reviews, which is about what are the sex differences in the impact of ionized radiation for astronauts. And because we have our initial search has over 50,000 results. So it's a lot of data. So we need to prioritize which one we analyze first. And as part of the analysis, we also had to become different indicators. So the indicators we were thinking is about how much data exists for each type of part of the question, how quickly can we go through the data, how many studies is needed to get a useful data result, what's the optimum time to produce result, and how important that topic area. So we use that to rank our topics. Just to also kind of one of the problems you have also in space medicine is that the example I gave you of systematic review before, which was in elder people, you have a question that's directly is the same question that is in the healthcare. It's the same question we do in the review, but here there's not a lot of astronauts on space tourists, so there's not enough studies to answer all of the questions. So how we answer the question space health is we use data from studies done in analog missions or in simulation studies like breath studies, or we use terrestrial studies and try indirectly to judge them. So if I, for example, take this question, astronaut space tourists after space travel, we want to see which rehabilitation protocol works best, and we have certain outcomes measured in mind. This would be the original question. Then the next question we would be is looking at partisan bedrock study, looking at the same comparison. The next level question would have been, if you look at terrestrial population that is very similar to the astronauts, having done the same comparison in them and have measured outcome. Or you go further is looking any terrestrial participant, but that might not be exactly similar to come. That's the next level of question to ask that later. Sometimes we also go down to the road of animal studies. Also in this case, I'm not sure it would work very well. But the key here is, as you have had to go to other questions to look at a study design, you have more indirectness of the data. So it means you have more uncertainty of it. And so if I, for example, had the high quality data for the first question, I would say, rehabilitation A works better than B, and we have high quality come. If I had my data from one of the other questions going to the right, I would say there's a likelihood that rehabilitation rate works better than A, but it's likely, it's not zero. Likely is a weird word when people use it. How conceptually define is like how likely it is that another study would change the recommendation. So as you have lower quality study, it doesn't mean you don't use that recommendation. It just means that you're more prepared. You have to be more prepared that this recommendation would be overturned by the next study that comes out. So how do we choose the outcome measures? So the prioritization method, as you said, is that we're suggesting to ESA for the sex different project is that we involve all of these different stakeholders, and we use also a lot of documentation. Like in that case, we actually the biggest priority in that question was that the reason like there's a difference how much female and male astronaut stays is because of a report that is based on the cancer outcomes and the differences exist. So the cancer outcomes were prioritized in that process in our data analysis because it would have a biggest impact on the change of the policy if we have find data that demonstrate changes. And also because when you have 50,000 results and you want to be up to date because new research comes out as you're doing a review, you also have to come up with a workload strategy about how quickly you can do data before new data comes out that you can provide a response that is timely for the people to use them. Okay, so the next steps we had to do, this like innovation we had to do is come up with better search strategies, because there is no dedicated registry for space studies that is easy to search of SCAM, and that makes it very difficult. And search strategies are there to be systematic and replicable, and also minimizing our own prejudices. So because when you search your studies based on what you know about the literature, your pattern of reading articles or pattern of who you ask affects what article to choose. But with the systematic search strategy, that doesn't affect it. You have to design a search strategy to also overcome publication bias. We all know that positive studies are more likely to be published than negative ones. So that's the reason we look at great literature like conferences, space agency's website, and so to develop a comprehensive strategy. So in addition to searching main databases like Medline and Membase systematically, we also try to identify other sources that are very space specific and provide a search guidance. Unfortunately, none of these sources, they're actually designed in a way that makes it easy to do a systematic search with them, because the way they are, the database is structured, the search engine structure is not very well designed. And you can see we have a table available in the paper. I'm cited if somebody wants to see more detail, because we analyzed each of them separately. The next stage, one of the other innovation we had to introduce was how we judge generalizability. So one of the reviews we had, which was the rehabilitation study, we're dealing with bed rest studies. The issue is, it's not all bed rest studies are the same. They have done different. They had different levels of strictness, how well they did in following guidelines to simulate a microgravity environment that we wanted to look at it. So we developed the rating tool to rate how much is the bed rest study similar to that based on different factors, and used it as the indirectness rating, so that when you have different studies based on, not only rated them based on the quality of the study, but also how good they are in fulfilling the bed rest part, which was quite helpful. Yeah, so it's come. And I have to say, we didn't develop for any other analog machine because we didn't need it for our reviews, but it would be appropriate to develop them at some stage. This tool still needs further development and validation, and depending what outcome measure you're measuring, you're using different analog missions or simulation studies, and the tool would be looking different. Like if I'm looking at psychological outcome or loneliness, like you might look at anarchic studies, and there's a different type of tool. If you're looking at physiological outcome and you're looking at bed rest studies. So the next type of the issue we had, it was that in some of the questions we had to deal with, we had to not only look at human studies, but animal in vitro studies. There's always a tricky question when you need to do that or not. For the ones that we had about impact of ionized radiation, we decided we need all 3 study designs. There is a lot of work has been done about how to synthesize and quality assess human studies or animal studies, very little about in vitro studies and how do you combine them all with each other. So we use the methodology that Camarades has for animal study and Cochrane has for human studies, but the in vitro one we had to develop further. I know a lot of you are not lab researchers, so I don't want to bore you about the whole details about how to do it, but I just explain how we developed it. Because if you do something similar or in another area, you could use the same methodology. So what we did is we first made an assumption, how are we developing the checklist? It's we make an assumption. The in vitro studies are supposed to inform animal and human studies. So we technically are looking how far away they are from those studies, like how far away they are based on how they are done and how replicable they are. And based on that, and we took the literature that already exists, we tried to identify all of the elements of quality that people had in the literature. And then we consulted people, other experts in it, what would they consider a quality item, and we put them together into a checklist. And then we selected a range of studies that we consider good, low, and high quality, good, low, and moderate quality, and use the checklist to rate them and see whether it's consistent with our expert opinion or not, and then use that as a way to kind of validate the checklist. This was the literature we used for that, for first development. And the checklist we ended up doing had this was for the sex differences review. So you had the screening question because we needed to have enough information about the sex of the cells to be eligible. And then we had some question about sample selection, experimental setup, the reagent slides, which are important for in vitro studies because it means that whether the in vitro study is done well, and also then questions about risk of bias item, which is across all of the animal, human, and in vitro studies, you would have risk of bias items. And so so we're currently piloting and validating the checklist for those the reviews we have about impact of ionized radiation. Finally, one of the biggest problems we have is too much data, and it was manually not possible to do it. People might say, okay, if you have enough people, you can like screen 50,000 studies. The problem is if you have too many people, there's too many inconsistencies about how people stretch it. So you don't want to have too many people that don't agree on how to do the screening, affect reliability, but also you need to be quickly enough screen the studies before the study gets out of date. So if the production of the study in that field is a lot, so if your review takes a year to do because you have too much data, the review is out of date before it's even finished. So it's important to find other ways to do it. We use machine learning strategies to do that. And machine learning doesn't do all of the screening, so we still have to do manual screening afterwards, but it reduces the workload. It's partially because in our field, we are more interested in sensitivity than specificity. So we like if you have 50K results, the machine learning probably reduces to 20,000 or 10,000, but still you have to do manual screening. There are machine learning used for systematic review outside of space medicine. The thing that's special here is we are dealing with much more complex questions and complex study design. So it's more difficult to develop a machine learning strategy. So for example, in this case, we took a training, so 4 to 5K results. We did screen them, and then used different machine learning algorithms from the classical ones, text classifiers, and some deep neural networks, and compared them to each other. The classical machine learning algorithm did outperform the neural network, but very in a small size. I have to say, we are in the initial testing. We're still testing it with more data, so it might not be consistent. One of the things we noticed is that this algorithm is not consistent in different questions, so we have to actually test it every time we do a different question, which not works better. But this is like if anybody finds a solution how to do a better machine learning algorithm for the screening and data extraction, it can change how healthcare and evidence-based, like how evidence informs healthcare and how quickly it can inform it, especially with complex questions like that. So yeah, that's so after the only thing at the end just to add to it is that most of the space medicine questions we do have to now, a lot of them we come to the end to say, okay, there's not enough evidence to answer the question, but we need future research. But it helps us a lot to structure future research recommendation based on that. And so that's where we are at with a lot to come, and also helping us to see how we can structure the data in a way that the production is more efficient. So if people produce studies that are better reported, it's easier to, and report in the right places, it's easier to integrate into systematic review and inform policy sooner. So yeah, this was the end of it. Thank you very much for listening, and I'm happy to answer any questions.
So Mona, we'll be doing the Q&A towards the end. So maybe Susan can take over, and then we'll move to Q&A. Okay.
Cool. I'll hand it over to you, Susan.
Thank you so much. Thank you so much, Mona. And I think I've just disappeared from the screen. Oh, there you go. I'm in the desert right now, Mojave Desert. Please excuse me. It's pretty dark in Los Angeles. So I have my night light on. I think you can see me. So hi, everybody. Wow, I look like a floating head here. But with that, I am Dr. Susan Ipjor, and I am the CEO and president of MMARS and Avatar Medic. And today I'm going to talk about the work that we've been doing since 2014 in the field of space medicine. But my talk, and I'm going to put my video off. So my talk is going to focus very much on innovation, and in particular, incorporating exponential technologies. And I think this is an interesting field of space medicine But I think it's also critically important if we really are to succeed, to become, to have permanence in space as a species, and to live on a planet's surface like Moon and Mars. So every time that you have humans in the loop, you need to really take care of them, not only how they survive, but how do they thrive. So this is what we've been doing since 2014, being able to deploy a lot of the R&D of the different types of space medicine technology and innovating and iterating, optimizing it in our analog missions. So here you could see is one of the organization that I form is Avatar Medic, and you just see a collage of a lot of the crews. These are analog astronaut crews, which you'll see a little bit more later in my presentation, and in particular developing the first humanoid tele-avatar, telepresence robotic robot surgeon doctor. And this is going to change not only the paradigm of how we're going to do medicine in austere environments in space, but here also on Earth, in particular areas where it's pretty dangerous for humans to enter, or in areas of underdeveloped areas on Earth where there's no access to experts, medical experts, or equipment, so on and so forth. So let's move on to the next slide, please. Right, so here we go. So I am the CEO of MMARS, and we've been deploying and training analog astronauts since 2014 here in the Mojave Desert in California, United States. But we're also very heavily focused in novel frontier exponential technologies, in the research and development of those novel technologies, incorporating specifically space medicine, or what we could call med technology, right? How do you actually come up with an idea? How do you then develop that idea into a prototype, and then iterate, optimize, and to be able to validate, and then build your MVP? So that's more of the entrepreneurial aspect of the training as well, that we incorporate not only in the astronautic training missions. Next slide, please. Right, so for us, what we've done is we sort of like say, how do you use a scenario of an injured astronaut, right? So you see in this picture in the middle, there's an injured astronaut. Who's involved? What are the operational, procedures? Who are the players involved? It doesn't just take a crew to go and rescue. It actually is a continuum of multiplayers, and also a very, very organized, set of protocols and procedures, and the assets that you need to be able to actually rescue individuals, or in this case, injured astronauts, in a very dangerous environment. So in this picture, this is a very high level sort of image of all the players involved, the remote mission support team, the flight surgeons, the crew themselves that are on the planetary surface, all the assets, space assets, satellite imaging, LiDAR, the biosensors. All this has to work together, like all these players in a play. They all have to work together smoothly, seamlessly, to be able to actually execute that one goal, is to rescue the injured person. So this is what we've been doing over many years, is when you come into our missions, we actually train you and divide this sort of paradigm continuum that you see here, and train the crews in the modules, and they learn the protocols and the procedures, as well as being able to develop some of the technologies. So yes, we integrate drones, we test rovers, we look at wearables, we bring in and look at LiDAR, we look at nano satellites, GPS coordinates. How do you actually communicate when you're in an austere environment? So even developing the 5G, testing that, build out repeaters out here so we can actually communicate, a distance from the hab. I mean, these are questions that we haven't solved. So how can we even think about living and going to deep space and living on the surface of a planetary surface when we can't even actually, do this on Earth in a seamless, very coordinated manner? Next slide, please. So here you go. right? So we've deployed to austere environments. This is actually, and somebody can, if you can actually see where the hab is, this was at 15,000 feet in 2019 with the first full analog mission, and it was a space medic. So all the crew were medical trained physicians, healthcare providers that were part of the crew, and we deployed to 15,000 feet. And you could see how austere, how isolated it is, and also the high altitude. Subjecting the crew to, the austere environments, the extreme cold, and also the altitude. Then, we had to ensure that the crew didn't succumb to high altitude mountain sickness. So we were also there to develop the technologies. Does the technologies, that you're building, that you're creating, developing, does it work in these extreme environments? And I can tell you, it didn't, right? The extreme cold, all the electronics didn't work. We had no sun, so we had solar powered, equipment. None of that worked. We only had 6 hours a day of sun. So, so these are the reasons why we deploy these analog missions to these austere environments, but also is to look at the human factors. How do we take care of the crew members, right? How does the environment affect them psychologically, physiologically, and physically? Because that also impacts the crew mission objectives. So we are going to go back to Everest Base Camp in 2020, next year, 2022 and 2023, when the COVID is more managed, of course. And we'll continue going to austere environments, primarily because of those reasons, to be able to test technology and to also test human factors. Next slide, please. So I just find really exciting is that, as I said, if you have humans in space, you're going to have to take care of them. But to date, all the crews, even the crews that on the ISS, most of them are not medical trained or medical doctors. Most of them are, in other disciplines, and they maybe have a minimum of 6 to 8 months of actual medical training, but that's it. So what if the medical doctor is down in the crew, right? What happens then? Does the other crew members, do they have the knowledge, the skill set? And that's the question that, we always ask, and that's what we try to do. So since 2014, we started developing and training what we call space medics. But at the time it was called Mars medics, but now it's space medics. Basically, it's the same analogy as on Earth EMR, the emergency medical responders or the paramedics. So we're using that. We're using the gold standard protocols and modifying it for the space environment. And in here, you can see in this slide, down the bottom, all the different images of actual analog astronauts who are space medics and on the space medic training program. And they're doing search and rescue. They're doing medical triage. They're doing evacuation. How do you evacuate the injured astronauts? How do you do triage of multi-astronaut victims? I mean, these are scenarios that we throw in and we train them. And then when we bring them back to the hab, they actually undergo and learn how to do basic, medical intervention like anesthesia, intubation. How do you do basic surgery? So these, I think, are critical skills that you have to be able to train non-medical individuals in the crew, right, to ensure safety, because always, it's humans in the loop, safety first, because we're not robots, right? So you've got to be able to take care of the humans. And I think there's, I think in this field of space medicine, it is the future, especially in the commercial world, when it's now opening up, where eventually in the next decade, thousands of civilians will have the opportunity to go into space. And what does that mean? That means there will be more high risk of injuries, of life-threatening situations, medical situations. So you need to have trained individuals to take care of them. And that's what we're doing. Next slide, please. So here you just, I won't go into it, but this is part of the training where you see some images of the analog astronauts, and they're coming in and they're using all the technologies, the rovers, the drones, the wearables, but they're doing the different protocols and they're training, you know, as I said, in search and rescue. They're doing the, how do you, I mean, you have to know how to actually do triaging. You know, how do you stabilize the person when they're injured? You know, how do you then evacuate them on the backboard? I mean, there are procedures that you have to learn. And then on the upper right, you can see, and I'll talk a little bit about that, the robotic arm that we're using. This is part of the early prototype we're developing for this humanoid tele-avatar, tele-robotic surgeon. And in that, you could see the 3D printed robotic arm being controlled 300 miles away by a medical expert that's working the arm, but also telementoring the crew here. And they're all non-medical individuals. These are artists, they're engineers, they have no medical background, and they're trained, and we're training them how to, the acquisition of skills for how do you do tele anesthesia, how do you intubate, how do you do surgery. So this is really the future paradigm of how we're going to be able to train crews, how we're going to be able to deploy and to be able to conduct medical interventions in very remote, austere environments. Next slide, please. And here you just see in the analog missions, some of the crew members coming in, and there's a pre-sim training, and they're doing basic medical training, right? They're learning how do you apply a tourniquet to stop a massive bleeding or hemorrhaging? How do you pack a huge open wound? Basic skills, you know, it's needed, I think, certainly when you're deploying to dangerous environments. So next slide. And this was actually a mission that we did at MDRS, the Mars Desert Research Station, very early on. And also we did the station to station in 2019, but just showing you, even, you know, using all the technology. And yes, look at that one picture here. It's amazing now, where most people have never ever used a map. Would you believe that? No, if you actually have, we've actually interacted with crew members who've never used a paper map. They did not know how to take latitude, longitude, just basic information. So now we have the cell phone, which has GPS, and you can just go on that and get your coordinates. But it happens that in our missions, when you have your cell phone dies or your equipment doesn't work, what do you default to? You're going to default to, analogs, and you're going to use, example here, paper map to find your way, or even using constellation, right? The nighttime constellation. But here I was just showing you how we integrate and how we do triaging and how we did search and rescue in the mission, and training the Mars medics or the space medics. Next slide, please. Yes, this was really, for this slide, I wanted to see in the middle here, this was us at 15,000 feet. Really was a very hard, challenging mission, the first of its kind. And you can see how austere, where they had to not only deal with the physiology of high altitude, but also the extreme weather. And the terrain itself was pretty dangerous, very steep gradient that they had to climb up and ascend. And so it was really also to test them in their resilience, building their own ability to be able to build the strength, the inner strength, right, to be able to conduct these hard protocols in this environment. Next slide, please. This one is just giving you just a little bit more of the Nepal mission when we went up there, and them, as a crew working together, basically training in the 4 C's, as we would say. How do they communicate, collaborate, cooperate? And, it helps with crew cohesion, which is vitally important if you are to, maintain the mission dynamics and optimize their performance as a crew, and to be able to perform and to achieve mission success, right? All the objectives of the mission, they have to accomplish and complete before the mission's over. So just this image here to show you, the crew worked really together well together. But in this mission, we actually had a medical emergency. And so we literally had to trigger the medical emergency escalation protocol, where we had a support team a mile away, and they were staying at a base camp. These were all the porters, Sherpas, the experienced climbers. They knew the terrain. They were very involved with the Nepal medical team, the hospitals. So we had to do one evacuation, but we had the support team. Of course, in the simulation, you stop the sim to be able to make sure that you're going to give the support for the injured astronaut, and be able to take care of that injured astronaut before you continue the simulation. So that was an interesting experience, and it was a team of doctors, thank goodness, right? Everybody was very well trained, and we knew, we could see the early signs and symptoms of high altitude mountain sickness, and we were able to make quick medical decisions. But what if it was a crew with no medical background or very minimum training? What would happen? Well, I can guarantee it wouldn't be a good outcome. And so this is why we also deploy to these austere environments. And next slide, please. So the space clinic paradigm is absolutely something that we've been doing, and you can go to the next slide. So in our missions, we use a prototype dome, and then we designate that to be the medical facility, because you're going to need that. You're absolutely going to need a medical facility on the surface of Moon and Mars, and even on the spacecraft, right? If we're going to build the commercial space station, you're going to need a area designated where all the medical equipment and all the medical capabilities are there for you to go. So in our missions, we actually train the individuals to be able to to do the telesurgery, to have the equipment there. So what happened to the presentation? Oh, next slide. So here you can see when we bought this is a simulation, and we actually rescued in the simulation the injured astronaut coming into the back to the hab, and then how they're going to conduct the surgery or the teleanesthesia. And what's interesting here on the right is actually he was in the crew, and he was a trained disaster medicine physician scientist. And what he's holding in his hand is called the butterfly. This is going to change the way that we're going to do diagnosis in austere environment in space. And it is a portable ultrasound device that is connected by Bluetooth to the cell phone. So you can train to use an ultrasound now using this application and using this device and this technology, because it allows you to be able to look at the images in real time on your cell phone when you're placing the ultrasound device on the body of the person, right? The patient or the injured astronaut. It is an amazing technology. And I think ultrasound for space is the only modality at this point is viable for on the International Space Station. Is what they use is ultrasound modality. And I think this is going to be the modality that we're going to be using in our missions, but also, when you're thinking about on the planetary surface of Moon and Mars, I think as a quick diagnosis, this is the one that's most effective. Next slide, please. So this slide is really showing you what we've been doing is using technology, for example, 3D printing of medical tools that we've done over the years, and then exponential technologies we brought in. So you can see a lot of the crews using and 3D printing a lot of the medical devices. One is called the vapor jet, which is this is going to change the paradigm of how we're going to do anesthesia in space. It is a 3D printed anesthesia inhalation device, and you can see them holding it here and incorporating it into the anesthesia intubation protocol. So we're training, most of these crews are non-medical crew members. And yes, and the study we've been conducting and asking the question is, can we train non-medical individuals to be able to learn how to do these basic interventions. And to date, over the years, I would say the data has shown, yes, the acquisition of skills and knowledge for non-medical crew is possible. And then the second question was, what is that time difference where, to be able to to retain the information. And so we're testing, is it 1 week? Is it 2 weeks before they perform it again? And how much of that skill set have they retained? And that is critically important as well, right? And so that's what we've been doing, not only, in incorporating technology, but also developing the protocols, the SOP, standard operation procedures, in these particular, anesthesia and surgery. And so we also, talked about the robotic arm. And so let's move on to the next slide. Now, the Avatar Medic is what I said, developing the first humanoid tele-robotic, tele-avatar presence robotic surgeon. I don't know if I'm able to play a video. It's only 2 minutes to show this to you, if that's possible. Let me see if I can share my screen. Give me a second, and I want to show you. This is the concept, and this is the future of how we're going to deploy medicine in space, but here also in austere environments. So let me see if I can play this for you. Here we go. All right, do you see my screen?
Yes, Susan.
Okay, here goes.
Dorian, it's so nice to meet you. So I'm Dr. Dewberry, and I'm here to take the neurology exam. I just need you to relax and just follow my instructions, okay? First thing I need you to do is to keep looking directly at my eyes and then follow my instructions. So this is the pen light, and I'm going to shine it into your eyes now. Okay, keep looking at me. That's great. That's right. Good. Now I'm going to shine the light in the other eye, but keep just looking directly at my eyes. Right? Okay.
Okay, so
wonderful.
That is actually an example concept of what we're building. The idea of bringing somebody, an expert, a doctor, a physician, coming in remotely into the robot, but as a tele-avatar, tele-presence. At this stage, it's very early, but then you're going to incorporate, spatial computing, which is the HoloLens or Magic Leap. You're going to incorporate also, biohaptics, biosensors, and then the convergence of all these technologies will allow that telepresence or tele-avatar expert or the doctor be able to actually interact with the on-site crew team and be able to not only, it's the humanoid, so it has all the sensorium. So not only to telementor them, but also to be able to help them with the intervention. This is the future of medicine. This is the new paradigm change of how we're going to be able to provide medicine in space and also here in austere environments. Now, the next video I would like to show you is actually how to do search and rescue with a drone and with telemedicine on board and a rover and on a planetary surface. So let me share another video. I think, this would actually give you a good sense of, what we're doing in terms of how do you apply innovation and technology to be able to solve some of these challenges of providing medical care in austere environments. So another video here, and this is we call the MediNaut concept. And so I'm going to share. Now you can let me know if you can hear and see the MediNaut concept that we're also developing and testing in our missions. So let me know, can you see the video?
Yes, Susan.
Okay, hopefully you can hear it. So can you hear?
Yes.
Are you able to hear? Okay, wonderful. All right, so this is the MediNaut concept. You integrating drone, the rover, and telemedicine on board. far ahead in the future, but that's what innovation and being, you know, thinking out of the box is about, right? It's really about how do you take those concepts and make, first of all, a very crude prototype, and then do what we call rapid prototyping and build then and test it, validate it, proof of concept, iterate, and then have an MVP, a minimal viable product, right? And that's kind of what we're doing in the mission. So even in those videos, some of those ideas are already, you know, some of the technologies, crude as they are in the research lab arena, right? There are groups doing these, you know, some of the early research. And so maybe it's not too much into the future. We're not too crazy, as they would say, right, with this vision, because I'm going to use always the analogy of the cell phone. You know, when I was born back then, you know, I saw Neil Armstrong step on the moon at 7 years old, and I never thought I'd be talking to you, you know, on Zoom, on a, you know, on a video platform, face to face, in real time, and being able to do this communication back then, you know, 51 years ago, when we saw Neil Armstrong step to the moon. You know, the capabilities of that, to enable us to do that with our cell phone, it's 100 times more powerful that we have in our hands than what they had to be able to land humans on the moon. So I would always say to anyone here is, you know, if you have a vision and a concept and it sounds impossible, no, don't think of ways, think of out of the box. And that's what we use space for, is out of the box thinking, right? To be able to help solve these huge challenges, this problem that you posed. And that is what, you know, Avatar Medic, that is what, you know, the idea of the Medinaut is about. And the fact that we can test them out in our laboratory, in our missions here in the Mojave, gives an extra, you know, like, okay, we can do this because we've got this ability, we've got the resource to be able to do it. So with that, I think I would like to end my presentation, and thank you so much. We probably have any time for Q&A with Mona and myself. Thank you, everybody.
So Mona and Susan, as you can see on the screen, we have a couple of questions. So Mona, the floor is yours.
I think the question, I put the questions up as the questions are to Susan. So I was just wondering whether the same setup are used for training individuals for other things like remote or disaster areas, because it sounds like it's very similar. And I just wondered whether you have used it in that way or also or not.
Oh, absolutely. Yes, that's a great question, Mona. I mean, that's a great question, whoever posed that question. But yes, the idea of space for us as researchers and scientists, let me see if you could see me. I don't want to lose. So this is kind of strange for my face like that. But anyway, so the idea of doing simulations and to do research in space, for space, is actually the connection back to Earth. So for me, I am going to take myself off video. It's strange like that. So for us, it's really using space to improve life on Earth, and that is critically important. That huge connection. So in developing these protocols and technologies for space, you know, in space medicine, is how can we apply the same procedures for austere environments here on Earth, for disaster areas, for areas where humans can't enter, but robots can, or drones, right? And then having the ability to be able to conduct these interventions for those particular scenarios here on Earth, as well as obviously for space. Yeah, that's really important.
So yeah, this was also another question I had. It's that, is there any, like when you've had space medics in that analog missions, any innovations came up from people trying to adapt to the situations that, and what did you keep a record of them, or does that happen, or people usually follow the training procedure?
Oh no, I think it depends on what the we're very open to, because if it's early in the study, then we're very open to ideas and being, you know, adapting, right? As researchers, you have to be able to do that. So, but obviously, if it's a very strict protocol that has been validated and we want to, you know, just to be able to collect more data, then it's very, you know, restricted and not as adaptable. But early in the designing of the study, absolutely. And it's interesting as well that during during the execution and of the study, you get some great feedback, and you get people saying, oh, how about we try this, how about you want to do that? And that's how you iterate, or that's how you're going to optimize the technology or the procedure that you're working on. So yes, absolutely.
Okay. So my final question is also mine. So what is when you have the training session, what is it the spacemen they struggle most with during the sessions?
Interesting question. And there's the response can be, I don't have much time to go into it deeply, so I'm just going to say it's multifactorial. The one thing, and depend on the fidelity of the missions. So obviously, the higher the fidelity means that there's more risk, and it could be life and death. So obviously, you need to select the crew that's highly trained. So the lower fidelity, I mean, it's the human factors. That's what I'm going to say. In every single mission, no matter what the fidelity of the mission, it's always down to the mix of the crew and the human factors. So I think that is one major unpredictable factor in the equation, right? Is your crew mix, as well as the skill set of your crew. Secondly is the ability for the crew to adapt to the environment. The environment is, if you go to austere environment where it's extremely hot or extremely cold, and the individual hasn't trained or adapted to that, it affects what we call the 3 Ps. And that affects them physically, psychologically, and physiologically. And if it affects them in those 3 Ps, inevitably that's going to affect the crew dynamics and also the performance of the crew. So and there's much more as well to this question, but we don't have the time to do a deep dive. But that's one of the most struggle. And also the equipment, when it doesn't work, as we all know, on Zoom, the frustration of just the equipment not working, right? It really does affect the crew.
Very true, very true. Thank you very much, Susan.
Oh, you're welcome.
Anybody else has any questions that they didn't post or want to raise now? Or
so I think those were all the questions from our participants, and that brings us to the end of this session. So big thank you to Susan and Mona for such an insightful and wonderful session on systematic reviews in space medicine. And I'm sure everyone thoroughly enjoyed this session. So once again, thank you for taking up the time and joining us. And for the next 2 hours, we will be in Wonder. So everyone, I hope to see you all over there. Thank you.
Thank you so much. Thank you.
Bye.